you hear me?
You're a bit quiet. Can you turn yourself up a bit?
Yeah, one second. Better?
Uh,
Better?
that's better. That's better.
Wait, this one should be better, right? As I'm better like this?
That is better. I can turn you up on my side. That should be okay. It's a bit quiet, but that's fine.
Yeah, put the lowest one. And okay, how are you doing?
I'm doing fine. Go ahead and log into the link I just sent, and we'll kind of get started. Can't be dilly dallying all day. So
What time you have? You have in Vancouver?
Vancouver right now, right? Vancouver's at 11 a.m.
Mm, I'm in Toronto, so I have like two. Okay, can I? Let me see if I can write something. Okay, can you see what I'm writing?
Yes, yes,
Whatever,
yes.
is all good. Okay,
What's your preferred
okay,
language?
nice. Python.
Python's good. Okay, great.
Python's good.
Yeah. So let me just lay this
Yeah.
line a bit. Um, so this is going to be it's a mock interview. It's going to be so we're doing an hour long, okay? And the format's going to be we'll just get
Yep.
right into it, and then you usually get about in an hour long interview you'll usually get about 45 to 50 minutes of actual time, and about 10 to 50 minutes of like stuff at the end. So first introductions, questions, etc. We'll only be doing the 45 to 50 minutes implementation, and at the end will be feedback, notes, questions, etc. Okay, so any concerns about the format before we get started?
Makes sense.
Okay,
No, it's
great.
all good.
Okay.
Let's go.
All right, so I'll dictate the problem. Please feel free to ask me questions whenever you have them. So today's problem, we're going to do merging lists. Okay, we'll be merging two sorted lists. So I would like you to write me a function called merge list,
Mhm.
and you'll take in the heads of two linked lists,
Okay.
and then you'll return the head of a linked list, which is the head of a list that is all merged. Does that make sense?
Yeah. Do you need to define the linked list structure and all of that?
There it is.
Okay, good. Thank you. Okay, so yes, it's node one, it's node two, and I need to return a head, right?
Yes, the head of a linked list, which
A
is the
head of
merged
the
list of the two.
merge.
Yes.
Okay, makes sense. Okay, what did I define it? What was I saying? Was not closed, right? Uh, wait, let me. Oh, I didn't num them. Okay, let's see. List one, list two. Is it good? I think was not closed. Do you need to even define that it's a list node?
What do you mean?
Like that I specified, saying that it's like, what is it saying? List node is not assets.
Yeah. So
Is,
so
is
uh,
it
so
saying
this
that because I don't return nothing?
so this isn't Python syntax. For Python syntax, you put the type after the.
Oh, after, yeah, sorry.
If you
That's why it's
prefer a different
sometimes like
language, we can
optional
switch
or something.
languages. It's not a
Okay.
problem.
No, I never really define like actual right classes in Python. I just do like, lead code and stuff. So most of the time it's already defined. Yeah, my bad. Okay. So we have two lists, right?
Yep.
We have list one, for example, I don't know, 1, 0. They're sorted or they're not sorted?
The two input lists are sorted. Yeah.
Sorted. Okay. So we would have like 1, 2, 5, 8. What's the constraints? Can they be empty? Can we have like both of them empty, one of them empty?
They could both be empty. Yeah.
Okay. Both of them can be empty. Okay. And for example, this one has like, can we have negative numbers?
Yeah. They can have any numbers.
Okay. Okay. Sounds good. So we would have like -5. Let's say 0, and let's finish at 8. Okay. we can have like two, I'm thinking about like two pointers at the head node of each linked list. And then we're gonna compare the values of the two. Whoever has the smaller value, we make it. Yeah, actually, we need that. Yeah, we need the third list. Okay, yeah. So whoever has the smaller value, we put it as a head node. Create a new node, put it as a head node. Then here we go to the next one. Then we compare them again. Whoever is bigger, we create a new node and put him here. Then we go to the next one. So whoever has a linked list with smaller value, add it to the new linked list and move to the next one. Okay, for example, here we go to the 8. 8 is bigger than 1. We add 1. Then we jump again to 2. 2 is bigger than 8. We add 2. 5 is bigger than 8. We add 5. Then we have 8 and 8. Oh yeah, I forgot to ask. We can have duplicates, right?
Yeah, you can have duplicates. Yeah.
Okay. So will the correct answer would be just 8, or would it be just like 8, 8, so like double?
It would be double.
Like
It would have all the
disregard them?
elements of the original list. Yeah.
Double. Okay, yeah. So then, for example, here would be like, if it's less than or equal to, then we just add this one, and then jump to the next one. This list is empty, and whenever our list is empty, one of the list is empty, we're just gonna end the rest of the list that is left. The list. Okay. Okay. If we have, for example, empty list, and we have one with a one node, we're gonna compare. Oh yeah, we gotta check if. Okay, yeah, and then we just add this one. Okay, sounds good. Okay, so first we're gonna define the first node. First we're gonna do like current one equal list one, and current two is equal to list two. So we're gonna do while both of them don't reach 0, or both of them, yeah, basically they're not null. Okay, so while we have current one and current two, we're gonna iterate. Okay, so here at the start of this, we have -5, and here we have 1 for this example. Okay, so now what are we doing? We're comparing which one is the bigger one. So we can't just do max function. We need to, yeah, I think we just compare them manually. Okay, so if current one dot val is more than current two dot val, so if this one is more than this, then we add, yeah, and we need to create what we're returning. So returning would be list node. Yeah, list node. Oh, yeah. Okay. And we also need a pointer for it. So just do this one. Res.next is equal to this. Okay. Wait, and I need to make we just make new list, and the result will be just the start of that list, and then in the end we're just gonna return res.next. Okay, so here if the first list has a value bigger than the second list, we append the value of the second list. So new list dot next is equal to into creating a node. And so we need to create a new node. I don't think so. Let's try like this. Yeah. Okay. Wait. Current dot val. Yeah. Then current dot to is equal to current to dot next. Then if our value is less than current to dot val, so if this thing is less than or I think equal. Oh, if they're both equal, we can just move 2 pointers. Yeah, okay. Okay, so yeah, new dot list would be the current one, current one. And then if both of the values are equal, then we just add both of them. Yeah, so new list dot next is gonna equal to per one. Then oh, I never iterate. Yeah, okay. And new list equals new list dot next. You're gonna move the pointer. Yeah. Okay. Yeah, then I'm gonna move this, and then I just need to do this again if they have the same value. Yeah, actually, I think we need to create new nodes. Just create this node with the value of run2.val, right? Yeah, then we switch the pointer, and here it would be current1.val. Okay. And here would be new dots. Yeah. Then we switch to next one, to this one, and then okay, makes sense. Okay. Now what else do we need? We iterate through all of them. Just removing. Oh, here I didn't move the pointers. Yeah. Here we need to move current1 equals current1 dot next, and current2 is equal to current2 dot next. Okay. So you're moving the pointers if they're both equal, and we take in the minimum one, whatever it is, move the pointer of the minimum one, and then do it again. Okay. Now, what happens when one of them gets to null? So, when one of them gets to null, we need to check if we have any lists end that are not empty. And we can do if this loop ended, so it means either current1 or current2 dot. So either we reach this, like null value, or this one. We can do, if we still have current1 pointer, then we still have current1 list. We're just gonna do new list dot next equals to current1. Yeah. Yeah. If we have current2, then new list dot next is equal to current2. Okay. Yeah. And then in the end, this is pointing to the dummy node, and the first value we put is actual next one. So first dot next. Yeah. Do you think that this looks good? Do you have any questions?
No, it looks good to me. Maybe a couple of questions just to kind of start the
Yeah.
thinking on this one. So in this case, I
Yeah.
guess you've assumed that it's sorting in increasing order. What if it was sorted in decreasing order?
Yeah.
What would have to change?
Oh, yeah. So we would have to, for example, we would have, let's say, 10, 8, 5, and we would have 4, 3, 1, right? So here I would say we would just, instead of getting the minimum, oh yeah, wait. Uh, so the first element should be this one, then this, then this. Okay. Yeah, so instead of here, then going to the next one. So I guess we would define some dummy node like newlist.next is equal to none. Then when instead of getting the smaller value, we would get the the bigger value. So for example, in this thing, we would get 10,
Mm-hmm.
but we would need to insert it. Let me think for a second. Mm.
Right. So just to clarify,
For
so
example,
we're on the
right
same
now,
page here, right? So
yeah,
we have
yeah.
we have the two input
So
list, which
you would
equals
want 1, 3, 4, 5, 8, 10, right? So we would still have it in increasing order,
yeah, you would
or
still return an increasing order, but to be giving a decreasing order. What would have to change about your algorithm to accommodate that list, to
yeah,
accommodate the new list? Yeah. Okay. Good.
yeah, yeah, yeah. Yeah. So for example, we created a dummy node, this dummy node, and it's pointing to none. So here, we would need to put, for example, 10, right? So we just go to the last one, and I guess we can try to like reverse the list, but I think it won't be as optimal. So I think we just put it, for example, that we would store, let's say temporary is gonna equal to new list.next. So we're storing this one. Then we're doing new list.next is equal to the higher one. So instead of this, we would do the higher one, that is current one.val. Then after we put this, we need to connect this one to the temporary one we had. So you would have new list.next. I think we can do .next is equal to the temporary one. Okay, so for this one it works. Let's see if we had a smaller one. So yeah, so all of this. Oh yeah, I know you need to move the pointer. So so you would move current one equal current one.next, and yeah, I think we don't need to move we'd have dummy and none like this. Yeah, yeah, I think here is good. Yeah, so here instead of this we would do same like this but 2. Okay, and if both of them were the same, we would need to basically input 2 nodes. So for example, here we would have like I don't know, 8 8, right? So we would input 10, loop again, and we would have this one and this one. So we have same values, and we would need to input 8 pointed to 8 and then again to 10. Okay, how we have done that? Let's see. So, oh yeah, and here it would be current 2. Yeah. So here we would still store our next value. Then we would create new list.next. So you would create this one. We didn't connect it yet. Then we're gonna connect it to this one, to the 10. And I guess we can just like repeat it basically.
Okay.
Yeah, I think we can just repeat the same algorithm. So we just store um, this one again, and we create a new value with same values. We would have like 8 and 8, but they're not connected yet.
Yeah.
And then we just, again, connect them, and we need to switch the pointers. I think so, right? Yeah, so we need to switch current 1 equals current 1 dot next, and we would have current 2 is equal current 2 dot next. I think something like that. Let me double check. This 3, this 3. Yeah, I think this one, yeah. And then in the end, in the end, 5, 1. So for example, we get to 5, or whatever, right? No, we get to, to 5. Then we go to the next one. And for example, we would have like 5, 5. We'd move here. We add 2 of these 5s. Then
Yeah.
we move our pointers, and this pointer is null, right? Is null. Then we just have the second list. So yeah, so I guess it should still work. We just, oh no, wait, no, it won't work. We need to do again. So we would have like, basically, like, let's just say 5, and we need to put this 1 here. So we would again probably do this thing. We would store our 5 and the temporary variable. Then we would move our next pointer from dummy to the one that we created, basically, to this one. And after we create it, we just link it to our 5. Yeah. Okay. Yeah. And then in the end, we just still return res.next, our dummy node.next. Yeah. Think it should work.
Okay.
Is there any? What do you think?
No, I think that's fine for now. Let's move on to the next one. Um,
Yeah.
actually,
Okay.
before we move on, let's talk about the time and space complexity of this implementation.
Oh yeah, yeah, yeah. So here we need to traverse both lists either way. So you would say one list has m elements and the other has n elements. You would just need to traverse n plus n, right? Yeah. And then the space complexity, what are we storing here? We're creating a new node, a new list with all of the nodes, right? Yeah. But actually, we're just storing the pointers. We're just storing one value at a time. So, uh, creating 2 list nodes. Is it, I don't know, all of one? Is it all of one? Because we're not storing the whole new list, right? We're just storing the pointers. Or is it still m plus n?
If we also include the return value, let's say put it that way. If you include the return value,
Oh yeah,
what would it be?
yeah, it would be m plus n then.
Okay, and
M plus
if you
n.
don't include the return value, what would it be?
I think we just all of one, because
Okay.
we're just storing like one value at a time, right?
Okay. Okay. Let's move on from that then.
Yeah.
Let's
Yeah.
we'll move to a second problem. It's a very similar problem, but I recommend making a new function for this, so don't modify the previous one. Um, in this time,
Oh,
we're
okay,
going to be
okay.
yeah. So in this time, we're going to be doing the same thing. We're going to be merging sorted linked lists, but instead of 2 linked lists, we'll have k linked lists. So your input will be a
Ooh,
list
okay.
of heads of linked lists.
Ahead of linked list. Okay. We just have one list with the list node, right? Okay. Okay.
So the input will be a list of heads.
Sorry. Wait. So this is then. Yeah, so this is an array of heads, right?
Yes, it'll be an array of heads.
Okay, okay. Just like this.
You can just submit the type for now.
Yeah, yeah. Okay. So you have an array of heads, right? Of the linked list. And do you know how many linked lists is there? Like k, right? We have it,
Yes.
right? Okay, okay. Okay. For example, we have, let's say, is equals to 3, and uh, we just have the heads. We would have like 1, 2, 3, and we have another array, like, I don't know, 2 and 4. Then the third array, 4 and 7. Okay, okay. Can we have k0? Right.
You can have k0.
Okay. If we have k0, then we just return none. Okay. So you have, I guess we have k1. We can just return that. We go. So like list 1 to 0. Okay. Okay. Now we have 2 and more. So I guess it's kind of like iteration. We just gotta again use our algorithm here that we did before. But yeah, let's think. So if you would just do it like iteratively, merge this and this, then the end result you just merge this and this one, right? But how much would it take? We would do n plus n and then another one, and we would need to store the values. I think. Is then the naive approach? Let's try to, I don't know, do it. Just merge first two lists. You merge them, you get a new list. Then you merge the list you got and the next one.
Yeah.
So I think I remember doing this problem, but I don't remember the trick. Let me think. A link list. A link list. I guess instead of just merging one by one, we would have like the we would have like 4, and then we have, I don't know, like 5, 8. You can just merge these two, get the our current one, and then merge these two. Yeah, so let's try to do it.
Okay.
So what do we need to get the first two values? We have an array. So an array, we basically just have this. Okay. So let me think, how can we implement it? We do while loop? I think so. Okay, let's try while loop. So while our is to define some index. So if I equals 0, so what do we want them to take? Have this merge list function basically, right? What do we want? We want to merge list the list. I don't know why I defined it list 1. We just do list at I and list at I plus 1. We want the first two. but we can get out of bounds if we can do that. So we need to check while I plus 1 is in the range, right? So if it is less than length of our list. Okay. Okay, so we got this one, we got these two, then we're gonna give it, it's gonna return a head. We're gonna just, let's say, new list 1.
Okay.
Then we want to do the same for new list 2. But, okay, here we need some conditions. So here we guarantee that we have at least I plus 1. And here we can have these, we have the third one, we can have the fourth one, or whatever. So, new list 1. Oh, wait. Can we remember the name? Okay. Oh, wait, I think we don't need to do it even at the same time. I think we just create again a dummy node. Okay. Dummy is equal to first of node. And dummy.next is gonna be equal to this. How do we get the end value? Ooh, yeah, so this one should be list.1. Then we move 1 second.
So are we just to clarify here, we're trying to do a brute force solution where we use our previous merge list implementation to merge all the pairs of lists in the array. Yes.
Yeah, I think so.
Okay.
Let me think if there is more optimal one.
There's definitely more optimal one, but we should maybe draft this one up first before we move on, so we at least have an answer, right? So the way
okay. Oh yeah, true. Okay.
Right. So the way I think with this is that we don't really iterate 2 at a time. We can just iterate 1 at a time. Right. So why don't we get a pointer to the first linked list, and then we iterate through all of the list from the second onwards. And we guarantee there's at least 2, right? Because these 2 conditions are checked. Right. So let's get a pointer to the first list.
Yeah. So current one is equal to list at 0.
Great. And this will be the head of the first list, right?
Yep. Yeah.
Okay. And then let's rewrite the loop a bit. Let's just do a loop through the list starting from index 1. So starting from the second element.
Okay. For I in range of 1 to the link of the list. And you're saying we just iterate by
just one by one.
By one.
Right. And we want to merge the current list with the current index list.
With the next one.
Right. And we
with the current one, yeah. Yeah. So we would have current one we have. We're gonna merge it with this one. Can just call we're saying our old function, it's like slow or not efficient.
What's that?
You're saying our we can't just do this one, right?
You can do that.
And whatever. Is this what you were saying?
Yeah, this would be a brute force implementation, right? Was this what you were trying to do?
Yeah. Current one, then this. Yeah, I was trying to merge it by pairs. But I don't know, how do we... You're merging these two? Is there a difference if you're merging it by pairs or if you're just merging it one by one? I think there it is, right?
Yeah, there's definitely a difference, but do you know what the difference is?
Yeah. I think we're merging one by one, then we always need to store our old value. If we just merge two of those, oh wait, we can just merge these two, then we just merge these two, and then we can just call merge on all of them, right?
You could, yep.
Like on the both one that we had. But if we would have more, for example, the first one, like whatever, what would we do? Um, Guess we can just like yeah, like minimize them, merge them by two, and merge them in pairs.
Yep, you could. I mean,
Let's see how would I
so I
would I
wanna just
implement
clarify
it?
that if you like, you can merge them by pairs. You can iterate to like, I mean, you can iterate to it a ton to merge them by
Yeah,
pairs. Um,
yeah.
but and so in that case, what would be the like? Is that going to be more efficient?
Uh, I think yeah, because we won't be storing the extra node, right? Because if you merge this one, we're gonna have another head. Then if you merge this one, okay, let me just think. So you're merging this one, we have like one, two, I don't know, two, three, four, right? Then we're merging with this one. Then we're gonna iterate from the list one, list two, retraining this one. Okay, what would happen if you had it in pairs? Um, I'm just doing the same amount of merge because this one takes one merge, this one takes one merge, and then in the end we have third merge. And if you do the just like this, like one merge, two merge, and the third merge. So I guess the time complexity is the same, but the base, mm, having two head pointers,
We can. I
then we're
mean,
just
look, we can do
merging
it. We can
them.
do it two at a time too. Just so we're not stuck on this, right? So let's just do it like
Yeah,
this then. So don't worry what magic is. Just assume that we get A and B. So it's two. It's pairwise, right?
yeah,
So what would you do then?
yeah. We just call the merge list on A and B.
Okay.
You're saying A and B is like this one, right? The first one and this and the
Yeah,
second
yeah.
one,
So
right?
so the A would be the pointer to the first one, and the B would be the pointer to the second one.
Yeah, yeah. Then we need to save that one, so we obviously can like whatever, like get the next one. I just say I don't know a oh it's iterating, yeah. Okay. Uh, and we would need to store this head in some temporary. So let's just say temp one. Then we're gonna store the next one and let me see. Merge this one. Did you merge the next two? Yeah. Okay, look. Just say do you connect it to the dummy node? We'll just say temp one is equal to the dummy node, right? Then temp1 dot next. Is it temp1 dot next? We connecting to this one, but oh no. So we just store the head. Then we would have like temp2 merge list. So to merge these two, we would need to wait for next iteration, right?
Sorry, to merge which two?
The next pair. You would just like wait for the next for loop, right?
Yeah.
For the next iteration.
So A B in the first iteration will be these two, and then the next iteration would be these two.
Okay, yeah, I see. Okay. You need to always connect them. to say, I don't know, temp1.next is equal to this, but these two. Oh yeah, every time. Then we need to merge our, I just say this is temp2, right? And then we need to call the merge on our current list and temp2. So, sorry, yeah. So this would be our temp2. Temp1 is nothing. We merge them and we put it into the let me just say dummy.next. Is that right? I think so, right? So we merge these two. Yeah, dummy.next. We merge these two. Okay, then we went to the next loop. We have this in the dummy nodes merged. We're merging these two. We have these two here. Then we're merging the, oh, we didn't update the temp one. Okay, yeah. So the temp one is need to again equal dummy.next, I guess. Yeah. Then we just again merge these and whatever we have here, we merge them too. Then we put it into the dummy.next. This one's merged, right? Okay, let's try, what if the B is empty? So it would be A and B. Okay, I think it still would work. Okay, wait. temp1.nan next. And try one more. We would have like, I don't know, whatever. 8 and 9, right?
Okay.
We have all of this in our dummy.next, the head, temp1. Then we merge these two again. We store it in temp2. Then we merge all of that we had before and these two. Oh. Okay. And then we just in the end we just would return dummy.next. Will that work? Am I missing something?
Okay. There is. I mean, I guess a question. I mean, we can just we can just go to analysis first. What's the time and space of this function of this implementation then?
Yeah. Yeah, so time one, it would be how much? Okay, so all of the lists have different sizes, right?
Yeah, they can have different sizes,
Okay, so we can
but you
have
can assume that for this Excel, you can assume that the longest one is
whatever.
length n.
Yeah, let's just say n. So this one would take like 2n, this one would take 2n, this one would take 2n. So would it be, it would be, how many times we're calling this function? For every 2. So I guess it would be n times what? Times the number of pairs that we have. So an, but basically, but we're just iterating. No, wait, no, we're not iterating through the list one time. We can iterate multiple times. Ooh, how much would it be? I'll just say the worst complexity. We just have like one, 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 one. To iterate through all of them, like uh, 1, 2.
So what did we decide the complexity of merged list was? Right, we said it was n
Yeah,
plus
so
n.
like
So basically
of
n plus
like
n.
two O of n, O of n.
Yeah, O of n. Yeah,
Yeah,
O of
O
n.
of n. Yeah. And then we're calling this loop. But the problem is like restoring the temp one, all of the previous one. And when we call it on the new pair, this pair is basically of n. And this pair, we again reiterating through all of the old elements. Would it still be O of n?
We can come back to that, but let's
Or
just write that down for now.
yeah, I think this one is yeah. Okay, the
But
space.
before we
What is the
get before we
space
go into
one?
space though, where's the K?
Yeah. Oh, K list. We have what like n times n
Okay, let's talk about space.
or no? Wait, one, two. Yeah, I guess it's k times n. Okay, and the space one. Ooh, if this one grows really a lot, but we just reassign it to every element, right? So we have the. I think it would still be all k of k times n.
Can you explain why?
Because we have. Let's assume all of this list, yeah, they're the same space,
Okay.
and our temp one grows. First we have n, then we have basically 2n, 3n, and the other two we merge in temp two. There are always 2n elements. So overall, I guess in the end, when we finish up in temp one, we store all of the elements in this list. And overall, there is k times n elements because we have k arrays, and each array has n elements. Not a linked list.
Yeah. Okay, so what's the overall space?
K times n.
Okay.
Yeah, because this one isn't gonna grow a lot.
Yeah. Okay. I see. I think I see where you're coming from. Okay, that
Yeah.
brings us to time. So, for the next 10 minutes or
Okay.
so, let's talk
Yeah, I
about
think this one
what happened here.
I
Yeah.
missed it. Yeah.
Uh,
I think maybe I had an idea of just minimize these two, but I don't know if it would work. Like, yeah,
okay. Yeah. I mean, we can talk about it. So, I mean, let's start from the top. I won't go through all the notes. I can see the notes after.
yeah,
But the first problem, we'll just kind of glaze through just really
yeah,
quickly. Not really much to say.
yeah,
There was something I wanted to say that was unnecessary, which was that you were allocating new nodes for every merge. That's not
yeah. So
necessary.
could I use the old one?
I mean, you didn't ask, but
Oh,
yes,
okay,
you could
okay.
have. But you should have asked.
Yeah,
Because
yeah,
this is why we're using extra
yeah.
space.
True,
If it was
true.
for this, it would be O1, but you are using this, so it's not O1 space,
Yeah,
right? Um,
yeah,
so that's a note there. Otherwise, it's fine. The follow up
yeah,
about the inputs being descending instead. The first thing you should have asked here, honestly,
yeah.
was just what's the requirement?
Mhm.
Like, do I need to make this time optimal? Do I need to make this like uh, like what am I optimizing for? And the reason you want to ask that is because if your interviewer just says, "Oh, I just want to see how you think," you should be going for the easier solution first, which is just reverse the linked list, right? There's no need to spend so much time on a more optimal solution than
But
that,
okay, yeah,
right? So yes, it is more
okay,
optimal, but I didn't really care about that.
yeah,
So it's always good to kind of check in on
okay,
that.
yeah,
Okay, so that's all about the first
yeah.
one. I mean, the second one's kind of where
So
the real
awesome.
real problem is. Any question about
Yeah,
the first one before we move on?
yeah, yeah.
Okay, let's move on then. Um, yeah, so obviously this is the real problem, right? The first one just a warm up. The main thing about the second problem here is
Yeah,
uh, you had a correct intuition. I mean, you said like you said you did the problem before. By the way, like in an interview setting, if you've
yeah.
done a problem before and want to be honest, say that up front. Otherwise, don't say it at all. Right? Saying it afterwards is not doing any good.
I do it to you because I. Yeah, yeah, yeah,
Yeah, but I'm not going to help you any more than a real interview. So, I mean, just like that's just for your note,
yeah.
right?
That's
For the
true.
future. Um,
Yeah,
right. So the main thing
yeah,
about this problem is that yeah, you had the correct intuition, but you didn't justify it correctly. You didn't understand why that was correct. So what is correct? The correct solution in this context, the one that you were going for, was a bottom-up divide and conquer. Okay, so I'll just continue down here, right? So the main thing here is that you actually had the intuition to merge lists pairwise, but the reason you described it incorrectly was because you didn't actually understand the benefit of doing them pairwise. And the reason you want to do them pairwise is you want to continuously do them pairwise, right? So let's say we had a list of one. Let's do this. Okay, like imagine these are heads, right? I won't write the arrows, but imagine these are all heads. So we have 5 heads, right? The first loop, we want to merge 1 and 2. Then we merge 1, 3, and 4, and then 5 just gets left out, right? Yeah. In the second one, we want to merge 1, 2, 3, 4, and then this will still be left out, right? And then in the third iteration, we want to merge 1, 2, 3, 4, 5. Okay, so what does that mean? This basically means that we will finish merging in the ceiling of log k. The number of iterations it takes is the ceiling of log k, right? And that's because we continuously pairwise merge them. So you can't just merge them once pairwise and then just do them iteratively like this. If you do it like this is the same complexity as if you did it the original way I proposed, which is just do them one by one.
Yeah, that's true. Yeah.
Right. It's the same thing. So
yeah, I just got lost on how to store the new pairs we got. Yeah, that's where I got lost.
Right. So and like one thing to keep in mind is that if you're not allocating new list nodes, I mean in this case you are, but if you weren't allocating new list nodes, it doesn't matter how you store them, because you're just rearranging pointers in existing memory. You aren't actually making new list nodes.
Oh, so you're just changing the actual list inside of it, right?
Yeah, you can change that. Yeah, I mean, I didn't say you can't. I mean, you should ask, but I didn't say you can't. And these pointer manipulation exercises, like it's meant that you're supposed to just move pointers around. You're not supposed to allocate new ones. Right. So this is the solution you were actually trying to implement. Now, obviously, I can tell, but I can't do it for you. So the hint given was okay. If you aren't able to justify this, you just get stuck. Like which is what happened here. Okay, what you wrote is the same as what I proposed. So in these situations, you should just be making the brute force one, right? If you can't figure it out, just write the brute force first, and then see what you can optimize. Okay. Now let's talk about another one. So another one, which is I would say is easier to reason because in this case you're trying too hard to think about the end situation. Instead, you should be thinking about how to reduce the problem space in the current situation, right? So, for example, let's say I'm trying to let's try to implement this, right? What you should be doing is, for example, now this isn't real code; it's just pseudocode, right? But you would be doing something like, okay, merge k link. Yeah. So call it recursively with the first half of the list. So 0 k divided by 2, right? Like so. Like so, right? So do it separately, right? Pointer 1, call it cur 1, right? Cur 1, cur 2, right? Merge them both recursively, right? And obviously base case, right? Base case k equals 0 or 1, right? Merge them recursively, and this way you also accomplish the same thing, right? So in this case, we're starting from iteration 3. We start with all the lists. We break it into 2, which would be 1, 2, 3. Let me start like this.
Yeah.
Right. This is what a recursive call will look like, right?
Yeah.
And we break it down further, kind of like this, right? And then so once you get k equals 2, right? If k equals 2, merge list AB, right? Right. And otherwise you call it recursively until it is k equals 2. Right. So if you do get stuck on these kind of bottom-up approaches, where you're trying to think about how the individual elements in the list play out in this divide and conquer algorithm, you can try to think about it recursively as well. Because that way you think about how, like, what do I need to currently do with my current list? How do I divide the current list to conquer it? Right. So this is just a tip for you, just going forward.
Mm-hmm. Yeah.
Does that make sense?
Yeah.
Okay, great.
Yeah.
And the last thing I'll say, which is not what you thought of, but a different solution, which I personally think is probably a bit easier, is using a priority queue instead.
Mm-hmm.
Have you used priority queues in Python, like heap queue?
Yeah.
Okay, yeah. So you should know that solution.
Queue,
Yeah. So these kind of solutions, I mean, it's very personal, right? you might prefer divide and conquer. That might be easier for you to reason. Some people find the priority
Yeah.
queue solution easier to reason. So don't be married to a single solution, right? Be like connect all these ideas in your head, figure out why is it that these
Okay.
all work, and then go from there.
Yeah.
Okay. So there's many
Okay.
different approaches,
Yeah,
and I
makes
won't
sense.
focus on that. You can obviously study it in your own time. I won't waste time on that. But one more thing I will say as well is about the time and space complexity analysis. So the first one was correct. That one's fine. You did well on that. By the way, it's good that you used M and N for the two lists. That's usually something people miss. Um, One thing you could also say, by the way, just to simplify in the future, I
Yeah.
think this is what you did is good, but you could also simplify and say, let N be the longer of the two lists, right? And then you could do O of 2N. So, it's the same thing. But
Yeah.
anyways, what you did was fine. Why that matters in your time complexity analysis for the second problem is that it's not like you're breaking an invariant, right? And the invariant is very simple. The invariant you're breaking is that in is no longer the length of the list. In was originally the length of the longest list. Okay, let's say we can make it simple. Let's say the all length in, right? The all length in. In is the length of the list on the first iteration, but guess what? Immediately on the next iteration, it's already
That,
2 in. Do you see?
yeah.
And then next is 3 in, and then 4 in,
Yeah.
and then 5 in. And then how big is it? It's k in at the
Yeah.
end, right? So if your list is
Okay.
on,
Yeah.
if your
Yeah.
list is k in at the end, that means the average length was k over 2 n, which is k in asymptotically, right? You can reason that in your head.
Yeah.
So that's k in asymptotic. So it's actually
Yeah.
not k in, it's k times
Yeah.
k times n,
K time. K. Yeah. Okay.
right? So that's kind of the reason here.
Makes sense.
So
Yeah.
So keep that in mind, right? In is the length of the list, but only at the beginning. But that changed, right? Because your
Yeah.
inputs over here is changed. Now it's two
Yeah.
and 3 and 4 and it's kn now. So you gotta keep that's tricky.
Yeah. Yeah.
So but you gotta keep in mind like if you're gonna do an iterative
Yeah.
solution like this, rebuild a list, this is gonna just be marked wrong, right? Like I mean like this is just wrong. So like you have to be very careful about that, right?
Okay.
Okay.
Yeah.
Couple. I mean we're a bit over time, but I mean if you have any questions, I'm happy to answer them right now. It could be either about the problem or in general about
No,
about the
I think
performance today.
it's yeah. The first one it was like easy just merge list. The second one it's like I understood the pairs one, but I just like I couldn't like understand how could I like carry over to the
Uh huh.
next like iteration, to merge them. And with the yeah, sure, like you said, I should have thought about it with the recursion. Because like yeah, I could have just made like two pointers and then like return it and merge them together.
You
But with the
divide and
I
conquer, right?
forgot
Yeah.
in the yeah, divided. That's what I was thinking. Like, I was like, okay, I can just like minimize them. Like instead of these two, I would just have one list. Then these two, then I just have one list. But how I couldn't understand like how could I like not memorize them, but carry for every iteration because that's why I tried to dummy next, and I was like, bro, I'm just doing the brute force. I was like, what am I doing?
Yeah. No, I feel. I mean,
Yeah,
like that's honest. I mean, there's two things, right? First of all, is like, yeah, you shouldn't be forgetting that if you've done it before, especially, right? So maybe go back, figure out, like, do it in more
yeah,
detail, do a little more analysis on it, be a bit more careful about it, and
yeah.
also, obviously, for this problem, you should try both the divide and conquer as well as the priority queue solutions. I think they're both good to know. And then also, just in terms of strategy, right? If you're not able to reason the optimal solution, and there's time pressure, you should just be going to write the brute force one just immediately, right? I'm assuming you thought of the brute force one pretty soon, right? So
Yeah, yeah. Just
right,
like iterate and get the next one.
yeah, just iterate and build a list, right? So if you can't think of optimal one, what you can do is and to be honest, if you're not confident you can think of it, you should just be writing the brute force one, buy yourself some time while writing it, and then think about the other
Okay.
one, right? So that way worst case
Hmm.
you just wasted some time writing the brute force, but at least at least you have
Yeah,
something down on the page and it doesn't look that bad.
yeah. Makes sense. Yeah. What would be the time complexity for this pairs one? Would be the same?
No, it would be so that would really depend on how it's implemented. This is not so we didn't get there, so I can't comment on it. But the reason it would depend is because some people still wouldn't use the correct. Some people don't merge it the right way because you can divide and conquer, but instead of doing it this way, you could do it like this way, right? And this is the same as
Oh,
what you did, right? So if you do it this way, this is the same
yeah,
complexity.
yeah.
In fact, it's actually well, it's not actually worse. But it's
Yeah,
about the same. If you do this way, then it's better. I think this way would be in log k.
I'm okay. Okay.
So
Would the space be the same?
no, the
I
space.
think space will be the
The
same,
space
right?
is the space will also depend, but the space would be log k ultimately.
Okay. Okay.
Yeah, it'd be log k if you didn't. So if you didn't allocate nodes, right? If you allocate nodes, obviously bets are off the table. If you
Yeah.
didn't allocate nodes, you just move pointers. The
Yeah.
entire
Yeah.
logic is O1 space, but because it's recursive, it's log k because
Mhm.
log k is the depth of your stack,
Okay.
right? Because you have log k depth
Yeah.
over here.
Yeah. Makes sense. Yeah. Okay. Yep.
Great. Okay. Well, that's all then. Thanks for your time. Thanks for participating.
Makes sense. Yeah. Thank you a lot. Thank you a lot for helping. Yeah. Are you doing the resume reviews today?
Yeah, I'm doing this for a while now. Yep. So you can come
Okay.
back
Okay.
at 2 p.m. in 2 hours or so. We'll do that.
Okay. Okay. Yeah. Thank you a lot again. See you.
Okay. Good. Take care. All right. So that was that. Let me get the next individual in. Okay. Oh, hello.
Hi, can you hear me?
I can hear you. Yep. Let me go ahead and invite you. Where is the
Okay.
that's the wrong button. Oh, here it is. Go ahead and join via that link. Be aware that the name you put in will be visible. And then we'll get started. I'm going to do a bit of housekeeping here, just clean up the previous session. Let's see. Cool. Let me know when you're in.
I think I'm in.
Yeah, I see you. I see you, potato.
Okay.
Cool. What's your preferred
Yep.
language for LeetCode?
Python. You
Python?
can leave it as
Okay.
Python. Yeah.
Yep, sounds good. Great then. So, anything I need to know before we get started? Otherwise, we'll just get right into it.
I mean, I haven't done an interview or like mock interview in a while, so yeah, I'm not that advanced.
That's fine. That's fine. No, we're definitely taking that into account. Okay, so
Okay.
yeah, so same as before. It's gonna be an hour long mock. Actually, be about an hour. It'd be about an hour long mock. In a real interview, it'd be about 45 minutes to 50 minutes of implementation time, which is what I'll give you today. And then usually afterwards, we'll do like questions, etc. I'll give you feedback, all that kind of jazz. Um, so let's get started then. For today's
Okay.
problem, I would like you to write me a function called sort. Well, actually, in Python, that's taken. Let's call it frequency sort. Okay, and it's going to take in a list of numbers, and I would like you to sort the list based on the frequency the numbers appear in the list.
Sort list by frequency in which they appear.
That's right.
Okay. So like if I'm given like 1, 1, 2, 2, 3, then you want it, then I should output an array that's like 1, 2, 3.
So
But in this case, we have like two numbers that have the same frequency. So then what do we do?
close. Not quite. We want to maintain all the numbers in the original list, right? So for example, if I may, we have a number like let's do
Okay.
2, 3, 4, 4, 4, 4, 1. I would like this list sorted in increasing order of frequency, and for tie breaks, you sort it by the natural order of the numbers, right? So we have three numbers that appear once, 1, 2, and 3, and because they all appear once, they need to appear at the front of the list. And the order in between, you decide which to put these numbers in, would be the natural ordering. So 1 is less than 2, which is less than 3, obviously. So I would like this in 1, 2, 3, and then 4 appears twice. It's the only number that appears twice, so it'll go at the end.
I see. Okay. So my initial thoughts are to create a hash map where you map the numbers to their frequency, and then we could just iterate through the hash map and then append values with the highest frequency first. And then if we encounter values that have the same frequency, then we would check which one is smaller first.
Okay. Yep. That's definitely one way to do it. Yep.
Okay. I'll call this def frequency sort that takes in nums, which is a list of integers, and then it returns another list of integers. Okay. So I'm gonna create a hash map called counts, and then I will just loop through nums and add it to counts. So for okay, so then now we have a hash map that maps the number to the frequency. And then I think I think like there's like a built-in function in Python where you can like sort by a given key. Can I
Mm-hmm.
do that or
Yeah, you can do
yeah?
that. Yeah.
Okay. Okay.
But
Let
do
me
you remember
think.
it?
Kinda. So it's like I don't know, like if I initialize a list, then I could be like uh counts dot sort. Actually, let me think. Maybe it's like sorted and then you pass in the hash map and then uh if you want to do like a custom key, you go like e equals lambda. And then we want to sort by frequency. So then it'd be like that.
How
The
confident are you
key
in
would
that?
be like
On a scale of 1 to 10.
like 5. I don't know.
Okay. Then I'm gonna ask you to not use that and write it out. You can keep it there. We can talk about that, but I'm gonna ask you to write it out. It's not quite right.
Okay.
But
Okay.
I appreciate you trying. But I appreciate you trying.
Then I will manually loop through each of the keys and values in the hash map for key value in. And then let me think. Like I want to get like the maximum value. Like I want to start appending the maximum values from this hash map first. But if I'm just iterating through the hash map, then I won't know where the maximum appears. You know?
Sorry, can you repeat the last the last thing you said?
Like I want to append like the highest values in the hash map first, but if I'm just iterating through the hash map
Uh huh.
pairs, I won't know like where the maximum appears.
That's true that we have it set up right now. Yeah.
Yeah. Um, hmm.
What if we don't have to worry too much about complexity first? Let's just get something that that's on the page and is correct.
Wait, what do you mean?
I'm assuming we're doing this for complexity optimization, like for efficiency. But let's not worry too much about that first. We're getting stuck. Let's just get something down that is that works.
Okay. Let me think. Okay, wait. So like at this point, if we're using like this array, then the hash map would look like uh 2 and 3 maps 2. Okay. Um, mm, mm, could I like mm, I don't know, like what if I like pop all of these from the hash map
Okay.
and then store them as like a tuple and then mm, I don't know, kind of stuck.
Okay. Um, one thing we can so I mean one thing we can do is just build a list up, right? So we want to know if so for a simpler solution, right? So we don't worry too much about efficiency yet, but we want to build up the list such that our condition is met, right? So I mean the hash map's not ordered, obviously, um, but we can just take the first. We can just take some arbitrary key, for example, or we can take all of the numbers that have a same frequency and process those together, right? So for example, one thing you don't have right now, but one thing that we could also build is after we generate the the counts the counts of every number, is to make a separate dictionary which maps a frequency to all the numbers that have that frequency, right? So in that case, we could have something like, for example, everything with frequency 1, we have you can choose what type you want. I mean, I'll make it a list just for simplicity. We have 2, 3, and 1, right? Oops, and then there'll be some items with 2 that occur twice in the list, like 4,
Oh, okay.
right? And so if you were able to generate this, would you know how to proceed?
Okay, if we had that,
Yeah.
then I could just iterate through each key in like ascending order, and then I would process each of the values
Mm-hmm.
in its corresponding array in like ascending order and then append it to the result.
Mm-hmm. Yeah.
Okay. Okay, that makes sense. Okay, so then I will build the second hash map called frequencies. And then I will do for for key found in counts. I will noise if found. Okay, I think that works. So I'm looping through each of the
Mm-hmm.
pairs in the counts array, and
Yep.
then I'm checking if the value, which is not in there, and then I'll initialize it with the list and then append the key. Okay,
Okay. Looks good to
and
me.
then uh, okay, now I want to process this array in
Yeah.
ascending order. So I guess I want to loop starting from 1 to whatever the highest key is, which I won't know, but
Uh,
Because like I don't want to process the same key twice.
okay, yeah, that's true. But how would you process the same key twice in this case? I'm not quite sure of that.
Oh, uh, because like if I'm looping this, if I'm iterating just using this,
Hmm.
then how would I know that it's in ascending order? Like, what if
Yeah,
this pair was like in front?
you wouldn't know if it's in descending
Yeah.
order, but you do know the keys of the dictionary, right?
Hmm.
So you have, well, this is probably the right dictionary you want, but you have, right? This is your frequency,
Hmm.
right? And here I mean, for your previous one, let's do, we can label these guys, right? So you did count dot items to get pairwise items. You could also do dictionary dot keys to get the keys of a dictionary. Would that help?
Yeah, I guess so. And then I could just check if the key is like one greater than the previous one.
Well, you would have, so if you did, for example, frequencies dot keys, this will give you a list of keys. Now the list of the keys might be in the wrong order, but it will give you a list of keys.
Oh, true. Okay. Then, okay. Okay. Then could I just do dot keys?
You could, but that might not iterate through the right order. But you would get a list of keys out. So it would be a list of, it would be like this would be a list type. So if you wanted to, for
Mhm.
example,
Could I just like do like sort or
of course you could do anything you want. You could do sort, yeah,
okay.
yeah, okay,
So then that would give me the keys in sorted order. So it'd be
okay,
like one, two.
yeah, that's right.
Okay. Key frequency dot sort. So then I'm getting these keys, and then for each key, I want to iterate through the values of that key in this map. So then I'll do for for okay, um, and then I will add these into this array, and um, and then I could do this.
So hold on. So we have, we're getting the values in
Mhm.
for all the frequencies, right? So
Oh, wait.
this would be a list of 2, 3, 1, and 4.
Oh, that is not what I want to do. I need to get this, I need to iterate through just the list for the current key that
Yeah,
I'm looking at.
that's right. Yeah.
Yeah. Okay. Um, key. I don't know if that works, but
Okay.
wait, like that.
Looks better. Okay.
Okay.
Right. Okay. So that makes sense. And what are we appending exactly? Can you be precise in this?
So we are looping through this array for like a given key, and we are appending each value
Okay.
in the list.
Okay.
And then I'm calling sort afterwards, which is
Okay. Is that
actually, wait, that does not make sense. I think that if I were to call sort, then it would sort the entire list, but I actually only want to sort the current like list that we're processing.
yeah?
Okay, then I could do like I could create a local list and then I will append to the local list
Okay.
and then I will sort the local list and then I will append the local list to this. Does that make sense?
That makes more sense. Yeah. Um,
I
well,
don't know if
I mean,
append is the right word. Maybe it's like extend because I don't want to append a list inside a list.
you're on the right track. That's right.
Extend.
Yep.
Okay.
Okay. And
Um, and then I want to return this at the end.
okay. Let's walk through the example we have. See how it works. See if there's any bugs.
Okay. So looking at this example, this is our input, and then I'm building this counts hash map. So I'm iterating through each number, and then I'm checking if it's not already in the hash map. I'm initializing key to 0, and then I'm increasing the value. So then that will give us this. And then I'm building this array, or this hash map, checking, I'm iterating through each pair in counts. I'm processing one pair at a time. Then I'm checking if the value is not there, initialize it with an empty list, and then append the current value, append the current key. Okay, I
And
think
can we
that makes sense.
so what will occur equal after this? Can we be precise about that?
Current, like this
Yeah,
list?
yeah. So what will that equal? Yeah.
Uh,
You can sketch it out, right? So for example, you'd say it equals what?
okay. Um, okay, so I'm getting the keys from here. Okay, dot sort. So then assuming that this actually returns this,
Yeah, we can assume that.
then okay. And then for value and frequency keys, so for each of these, then I'm just appending 2, 3, 1. That's what's happening here. And then I'm calling sort, which will give me 1, 2, 3.
Mm-hmm.
And then I'm appending or extending it to result. So that will give me that. And then I'm getting this key, and then I'm doing the same thing, iterating through the values in that, and then at this point, this array will just have 4, and then I'll call sort, and it'll still be 4, and then I'll add 4. Oh, wait.
Is that right?
Oh, wait. Wait, no, that's not right because there's like 2 instances of 4.
Mm-hmm.
Okay. Uh, okay, let me think. Uh, so I want to iterate this many times, like whatever the value of the key is,
Okay.
then I want to append. Does that make more sense? So like since the key is like 2 in this case,
Yep.
I want to append the value for 2 times.
Yep. That's right.
Okay.
And so what would it equal now? Let's just finish the example. We're almost there.
Okay. Yes. Okay. It will equal this. Current will be like this, and then I will extend it like that.
Okay. That checks out.
Okay.
Any other concerns you have about the correctness?
I mean, this is like underlined, so I don't really know if that's correct.
That's not, but we don't have to worry about that.
Okay.
Anything else?
Uh, mm,
I'm not saying there is. I just want to check if you think there's anything else that's wrong.
I mean, I don't think there's anything wrong.
Okay.
I don't think so. I mean, other than the fact that it's inefficient, but
Okay, that's fine. I mean, let's talk about that. What's the time and space complexity of the solution?
um, well, for these 2 loops, it would be O of n because we're processing each number in the input, assuming n is like the size of nums. And then for this part, we're also, the outer loop is processing n times at most if we have like n different keys. Like if there's, if all of the frequencies of the numbers are unique, then we would run this loop n times. And then I guess since there's another loop, there's like three for loops. So,
Yeah, there are three for loops, but it doesn't necessarily mean it's a bad thing.
true. Mm, mm, I think. Mm, I think it would be n squared, but not sure.
Okay, and just to clarify, right? N is the length of the input list. Is that what you're assuming?
Yeah.
Okay. Okay, so we're saying, okay, let's just put it at the top here. So we're saying time n squared. Let's talk about the space then. What do you think the space is? The space complexity?
Base would
Yeah.
also be O of n squared because we're building hash maps, and at most we could have like n different keys.
Yeah. You have two hash maps here, and they
Uh-huh.
both could
And
have
then,
at most in different keys. Yeah, I agree.
yeah, and then in here, we're also building like local arrays, but at most they would contain n items in the array as well. Same with the result list.
I agree, right? So these two can be at most length n. This can be at most. I mean,
Mm-hmm.
this is length n because this is like what it's meant to be. This you're also
Yep.
saying can be at most length n. So what is the overall
Yes.
space complexity?
O of n.
Okay. I mean, you changed your mind really quickly on that.
Wait, what do you mean?
You said it was n squared. Now you're saying it's n. Which one is it?
Wait, no, I said the time
Okay,
complexity
okay,
was n squared.
okay, okay,
Yeah.
okay. That's fine. We have more time left, so I want to just move on from this for now, and we'll come back to it in this discussion after. Let's
Okay.
try. Okay, so let's try a different problem now. Um,
Sure.
so we can just go underneath this. So this is
Okay.
sort of switching gears. So this is a different problem. In this problem, I want you to write me a function called validate. Okay, and it's going to take in a node for a binary search tree. And I would like you to return true if and only if the binary search tree is a valid binary search tree.
Okay. 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 Let me think. So, just to reiterate, we are just getting one of these tree nodes as input, and then I have to traverse this tree and determine if it's a valid binary search tree.
You're getting the root of the binary search tree, and yes, that is correct.
Yeah. Okay. Okay, let me think about this. Hmm. Wait, so just to clarify, a binary search tree is when the root node is greater than two of its children, right?
That's a heap. For a binary search tree,
Oh,
the
right, okay.
condition is that the left subtree, so the current node's left value, is less than the current node's key, than the current node's value, sorry, and that the current node's right value is greater than the current's value, and we can assume there are no duplicate values in this tree.
Okay. 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 Um, so, uh, what I'm thinking is, hmm, So what if I were to recursively traverse this tree and check that the root node is greater than the left child,
Hmm.
but smaller than its right child?
That sounds reasonable.
Okay. Hmm. So, okay, let me draw this out. So if I have a tree that's like maybe I'll make this like so this would be a valid binary search tree because the 3 is greater than the 2 and the 2 is greater than 1 and then these numbers are also greater than each other. Okay. Okay.
Yep.
Um okay, what if I do like a depth first search on the tree and then once I reach like a root node or like a leaf node, then that means I'm at the bottom of the tree, and then I can return back to the parent node, and then I would check. Uh, wait, let me think. Would check if. Okay, I'm like, I don't know if I should be traversing this like depth first search or breadth first search because if I do breadth first search, then I have to keep track of like the order of the nodes. Okay, let
Yeah.
me think.
Before
Uh,
we go too much into that path, maybe there's one more thing I wanted to check on, which is another example. So let's say we had this example here. Um, would this be a oh this would be duplicate? Would this be a valid binary search tree?
no,
Okay.
because this one is like smaller than this.
Yeah,
So
that's right.
it's on the right side of the tree, which, okay.
No, that's right. Okay, well, just want to clarify that. And then one more thing, maybe just to get us started on the right foot here is right. So thinking of depth first search makes sense. That we could definitely do that. But just to clarify, right, we're not searching for things. We're just we're just traversing the tree, right? What kind of
Yeah.
traversal? Like what kind of traversal are we performing to do to validate a tree in this context?
Uh, mm,
Do you remember your traversals for trees?
reorder, in order, post order.
Yep. And what are the characteristics of each? Which one should we do here?
Okay. So in order would be like I'm processing the left child, the root, and then the right child. And then pre-order would be I'm processing the root, the left child, and then the right child. And then post-order is like left, right, root, I think.
I think I got that right, but yeah. Which of those do we want to use? Which has the right
Um,
characteristics for our binary search tree? Right. So don't look at this. I mean, this is correct, right? So don't look at that one anymore. That one's not helpful. Right. We're looking at this.
okay. I mean, I think we want to do in order traversal because then we would be processing the nodes in ascending order, which might make sense.
That does make sense. That does make sense to me, right? We want to
Okay.
check that
Wait,
all the
okay. Yeah. Sorry,
okay.
go ahead.
Well, I mean, like, right. So to validate it's a binary search tree, all the nodes in the in order traversal must be ascending.
Yeah, okay. What if I do like an in order traversal and then I append all the nodes into like a list, and then at the end I could just check if the list is in ascending order? Would that give me the correct result.
That should give you the correct result. Yeah.
Okay, I think I want to try that.
Okay, let's do it then.
Okay, def validate 3, take in a root. So, okay, so to do the in order traversal, I'll initialize a list like that, and then I will, okay, maybe I'll initialize like a helper function that will take in a node, and then I have to check if the node is not there. If not node, return. Otherwise, so in order is I'm processing the left child and then the root and then the right child. So then I go like helper node dot left, and then I append node dot val, and then helper node right. I think so. Like I'm processing the left child,
Mm-hmm.
and then I'm getting the root, and then I'm processing the right child, and then returning this list. Okay. And then, okay, so I'm going to call this function with the root that's passed in this outer function. And then I'm going to get result equals this. Okay. Okay. And then I need to check if this is in ascending order. How do I do that? Let me think. I guess I could just like iterate through this list and like compare adjacent values and then check if the right value is greater than the left value. Does that make sense?
Yeah, that's one way to do it. There's many ways to check a list, but you can definitely do it that way.
Okay. Okay. So, okay, I'll do for I in range length of result. So I want to check. Okay, so I want to check if I is smaller than oh wait, actually I'll do if the current number is greater than the next number, then return false. And then otherwise return true, because then we've traversed the whole list without encountering this condition.
Okay.
Would I go out of bounds here?
You tell me.
Because, okay, if the list is like, okay, say the list is like 1, 2, 3, then I'm iterating 2 times. Then the first pass, I'm comparing 1, 2, and then I'm comparing 2 and 3. Like, I think it's fine. I think it's fine.
Okay. Do we want to walk through an example? You can use your example tree.
Oh, sure. Okay. So I'm passing in the root, which is 3, and then I'm calling this helper function helper, and then I'm checking if the node is null, return. Otherwise, I process the left child. So then I'm processing 2, and then I'm processing the left child of 2, which is 1. and then I'm trying to process the left child of 1, which is not there, so then I return, and then I append. Okay, I'll make my result first. So I append 1, and then I'm going back here, and then I'm processing the right child. There is no right child. And then I append this 2, and then I'm processing 3, and
Yeah.
then I'm checking if 3 has a right child. Wait, no, I'm first appending 3, and then I go on the right child 4, and then 4 does not have a left child, so then I append 4, and then I look at the right child 5, and then I append 5, and then 5 has no left children or right children, and then I return this list,
Mm-hmm.
and then I'm processing this list here. Okay. And then the range would be 0 to 4. And then I'm checking if these two numbers, so that would be the first iteration, 1 and 2. And then I'm checking 2 and 3. And then I'm checking 3 and 4. And then I'm checking 4 and 5. So 4 iterations.
Yeah. Yeah, looks good to me.
Yeah.
Time and space on this one, please.
Okay. Let me think. So this helper function will process all of the nodes in the input tree
Mm-hmm.
once. So then that would be O of n, assuming that the size of the tree has n nodes. And then here I'm also looping through this result array, which will have all of the nodes, so n. So then it would also be O of n in terms of time complexity. So it would be O of n. And then the space complexity, let me think. I think like for this recursive function, the stack trace would be the height of the tree, I think, on average case. But like if the tree is unbalanced, then it could be the size of the whole tree, which is n. But on average case, it'd be the height of the tree. And then for this loop, we're iterating through. Oh, wait, then, but if I'm counting this result array in terms of space complexity, then it would be O of n.
So what's the total complexity? Space?
O of n.
Okay. Okay. Sounds good. Let's wrap it up and talk about some things about both problems. Right on time too, actually, for
Okay.
about 45 minutes. Cool. Okay,
Okay.
so I mean, I like to generally ask you guys, how do you feel first of all, right? What's your confidence level? How well do you think you did need the
Uh,
problem?
I don't think I did that well. Like, well, for the first problem,
Okay.
I feel like I had like good intuition in what to do, but like I did not know how to implement the functionality. Like I forgot how this sorted thing works,
Okay.
and I kind of got stuck during this part.
Yeah.
But I
Okay.
feel like that's more of like I just need to practice writing more code. But like I think I had good intuition about the problem.
Yeah.
And then this one, same thing, I guess. Like I was a bit stuck on which direction to go in the beginning, but I
Yeah.
mean, I feel somewhat confident with the solution, I guess.
Okay.
Oh, I don't know.
No, that's good. That's good. I think that's a pretty accurate assessment of generally what an contributor would feel. But we can break it down a bit, and in a bit more detail. Do
Okay.
you want to talk about the first problem first?
Yes.
Okay. So I mean, I guess the first thing to say about this one is like, yeah, the I mean, using the sorted function is typically what people do, especially on LeetCode. But this is exactly why you can't just practice on LeetCode, right? Right? Because if you're on LeetCode, you go search out, oh shit, what's the hell? Like what's the key? What's the lambda? You
Mhm.
can't do that in real interview, right? So if you don't know it,
Right.
you don't know it, right? You can't just say, oh, and then this is how it
Yes.
works. No, that's not how it works, right? And also the way you have it set right here wouldn't be correct either way, even if the syntax was correct, because this doesn't do the tie breaking correctly, right? So
Right. Like I would need like a second condition to account for that.
yeah, you were actually pretty close to. I mean, to be honest, right? So you would. So I'm not sure if you're aware. So do you use Python for stuff outside of LeetCode as well?
No.
Okay, so that's probably why I didn't know about the breaking condition. So it would be like this. It would be this is how you would do it,
Okay.
right? But if you didn't know this, you can't use it.
Would you recommend like doing this for an interview, or is it better to like manually do
It's
it?
always better to do this because that's optimal, but most interviewers won't let you do this unless you can explain exactly what's going on.
Okay, yeah. Because I feel like I would not be able to like memorize this, and like if the conditions are like slightly different, then I would not be able to come up with the lambda function.
Yeah,
So,
and I mean this is another thing which is a really common thing I see because I'm an interviewer, so I see a lot of people come in with these kind of like not this problem obviously, but like different problems with lambdas and all that jazz. Um, One tip I'll just give just in general is obviously if you can use Python and more things, you can get more familiar with it. That's great, but a lambda is just an anonymous function, right? And so you can define a
mhm.
helper function yourself, and that can give
Oh,
you and that would be something you can do. So for example, you could do like this,
okay.
uh, def help, call it like get index or get key, or let's call it helper, and then you do your logic over
Hmm.
here. So uh, x logic, you do actually would be ab. So
Okay.
return compare ab, and then you would just put it over here. Helper.
Oh, like you would
So
just put the function name. Oh,
yeah.
okay.
So lambda is an anonymous function. So that's one thing you can do. If you're not sure the syntax, you can do it this way, right? But you still have to know that, right? So, um, right. So let's not dilly dally on that. Generally speaking, there should be a signal for you to realize that like don't lean on that too much because if you don't practice more, you're not gonna remember. Like you're just not gonna remember all the lambdas. You're not gonna remember all the things about the some other tips and stuff, right? So be ready to actually write out all the logic yourself as well. And I think that's a pretty good form of practice, just in general.
Okay.
Okay, so that's just one thing. The rest of the problem is actually done quite well. Obviously, you got stuck a bit on how this kind of thing works, like in terms of like a more
Yeah.
basic algorithm. So, and I mean, like this is not like a common algorithm you'll see. Like this is a pretty contrived problem, but I mean, most of these problems are contrived, and so it is up to you to kind of think of what the best way forward is, right? But I will say at least is that you were good and that you recognized that you were not making progress, this is not going well, and to ask for help. Um, Most interviewers in that context would at least give you something to kind of go off of. So, like if you feel like you really are stuck, that's not an issue to kind of look for.
Okay. Did I come like I'm assuming this is not the optimal solution, right? Like,
It is the correct solution given that you're not using this, but yeah, it wouldn't be
oh,
optimal.
okay.
Yeah. Um, yeah, and we can talk about this as well. So there's another reason this isn't optimal, and this is something which you didn't quite catch on the playthrough
Oh,
again.
is it the sort?
Yeah, it is a sort, but not exactly in the way that you thought of it. So, and this is like pretty deep arcane knowledge, so don't get too caught up on this, right? But it's not efficient to sort over here. Why is it not efficient? It's not efficient because cur has already been expanded with the duplicate keys. It's more efficient to sort before you duplicate the keys, right?
Oh, you're right. Yeah,
So
that's true.
so that's one thing, right? So you didn't cache on the second way around because in the example I only gave you two, and that's at the end. So it's not obvious, but that is a thing, right? Um, Other than that, it's
Okay.
fine. I will also say that in Python you should be using the counter whenever you can. the counter is super, super, super useful for basically a
Oh,
whole
okay.
category of
I don't
problems.
know. I just assumed that you'd want to see me write it out, but
I'd
yeah.
say nine out of 10 interviewers literally don't care. One in 10
Okay.
will care, and they'll just tell you. And you could always ask, right? Because
Okay.
it's I mean, like, I'll put it this way, right? Like, you're not using count over here, but you're using sorted over here. Like, what's that? You know, what kind of reasoning is that? So always lean
That
on
is
you can
true.
always lean on using counter. Just say, hey, I'm using counter. Is that okay? Do you want me to write this out? Right. Worst case, to write it out, you just write it out. Right. It's not hard. But it can save you time. Right. Um,
Right. Okay.
and detail, let's say, and I don't like talking about Python all the time because it doesn't really matter. But like, if you're using Python things, you kind of have to know it, right? So like, for example, sort is a function on ordered sets, right? And so if it's not an ordered set, you can't use dot sort. Instead, you should use this sorted processor, which takes an any iterable, right? So this is how would have been actually correct to use, because keys,
Oh.
it's an unordered set of it's an unordered key. It's actually a special type called dictionary keys, but don't worry about that, right? Now that won't fail the interview, but they'll know that you don't actually use Python, right? So for example,
I
if this is
see.
for a role where they actually say Python experience, right, that might be more of a yellow flag. But I'm just letting you know, right? Most people won't care, but if it is a Python role, they'll be able to tell, right? So just keep that in mind.
Okay. Okay.
One more
Makes
thing to say
sense.
about this problem is that the time complexity analysis is sort of correct, right? So this is O(n), this
Okay.
is O(n), like no one cares about that. What's going on here, right? So you are right in that. So this could be worst case in, and this could be worst case in, right? But
Uh-huh.
they can't both be worst case in. That's the key insight, right? If you have in keys, right? That means, or okay, let's say you have almost in keys. So maybe like in minus a constant number. So like not in divided by two, but like in minus, like let's say 10, right? That means this has to be constant space, constant time, right? Because you
Hmm.
can't have in different keys and for each key you have in different numbers,
Right.
right?
Yeah.
That's not
Yeah.
possible. So only one of these two can be in at a time. Does that make sense?
Okay. Yeah, that does make sense. So then overall, would it be n squared?
Well, so in your case, it would still wouldn't be good because you have a sort
Oh.
over here. So right, so still it wouldn't be in square. It'd be better than that. The analysis would be a bit more advanced, but it would still be proportional to n. It would still be proportional to linear time. Um, but I will say this is very very, and this is where the difference makes sense. Right now, if you're saying the analysis is n squared, it doesn't matter where the sort is, because a sort is at most n log n, which is obviously less than n squared.
Hmm.
So I don't care about that, right?
Yeah.
But if you're saying, okay, only one of these can be n at a time, which means that this is proportional to n, then it does matter where the sort is, because then the n log n can dominate the n. So like, just be prepared. One thing you should always keep in the back of your mind, and it didn't happen today, but one thing you should keep in the back of your mind is, if you're updating your answer for what the time complexity is, make sure that you actually make sure in your head that you have all the notes down for what's going on, right? So I have a tip for this. Generally speaking, if it's not trivial, what you should be doing is, for every loop, you should be writing the complexity, right? So for this one, just write, oh, this should be O in.
Okay.
So I won't write the
Okay.
oh, right. This is n, right? So this is counts.
Hmm.
Counts is proportional to the number of keys. Obviously, worst case it's n, so that's n, right? So this one you should also write n, right? This is n because it can be at most, it could be in keys. Also, by the way, it's actually a bit more than n because it's sorted, right? So this is already gonna be n log n, right? But
Oh. Yeah.
what's going on over here? So this is where you would keep in track, right? So for example, if you say for Valen, this can be at most n, right? So this can be n, but only one of these two can be n, right? At most n. So this
Hmm.
is how. So for example, you say, oh shoot, this is actually, let's just say this is like k or something. Oh, then now this is bigger than k. Then I got the answer, right? So I recommend writing these things down just as quick notes, and so later on it's easy
Okay.
to reference. And also, if they change requirements of the problem as a follow up, it's easier to see, right?
Okay. Yeah,
So
that makes
so
sense.
this is something which you should probably adopt.
Hmm.
Anyways,
Okay.
and yeah, in this case it will be extend is correct. Um, right? Append would have done what you said. It would have added the array as an item in the array, so that would have been good. But
Uh-huh.
extend is
Okay.
correct here. Yeah. Okay.
Okay.
Wanted to have a bit of time talking about the second problem as well. So let's move on to that one if you don't mind.
Yeah, sure.
Okay. So this one, yeah, this is all about traversals, right? This is basically testing how well do you know your binary search trees. And whenever someone's talking about validate, or whenever someone's talking about a problem where you need to visit every node, right? So validate, search you might not need to validate, search you might not need to visit every node, right? But for the validate or find min, find max, right? These things you would need to visit every node, right? Okay, maybe for a binary
Yeah.
search tree for a find min, but like a general tree, find min, find max, you would need to visit every node. And so whenever you have a problem where you need to visit every node, the problem is about traversals. That's the entire problem,
Yeah.
right? So how do you know your
Okay.
traversals? In this case, I have to give you a bit of a hint to guide you towards thinking about traversals. But once I told you that, you know it was correct afterwards, right? So you knew about the in
Okay.
order,
Yeah.
and you knew about pre-order, post-order, that kind of jazz. That's great, right? So you were actually pretty fast in kind of making writing the traversal. That was good. Um, a bit of a hiccup on the validating ascending. Um, you didn't seem very confident in that. Was there a reason?
I don't know. I guess I don't really do that very often. Is it wrong?
No, it's right, but you were very
Is
hesitant.
this like efficient?
Yeah, this is fine. This is efficient. Yeah.
Oh, okay. Is there a
Um,
better way to do it? Like, I wasn't sure if this is like too brute force.
there is a better way to do the problem, but not a better way to validate if an array is in ascending order.
Oh, okay. I just wasn't sure if this was like the most efficient, but I guess looking back, I wouldn't know what other way to do it. So,
Yeah, no, this is fine. It's fine. It's just that it was a bit weird that you were, like, I mean, you banged this out real fast. That was good, and then I mean, this took almost as much time. I was a bit concerned, like, oh, did she not know how to do that? So this is a bit weird. So calling that out, right? Like, if it's just lacking confidence, you should have more confidence. If you're actually not sure how
yeah,
to
I
check if
think it's
that's
like lack of
okay.
confidence.
Yeah. So if you're ever lacking confidence, just run your own example, right? Run that through. Now,
Okay.
so I will quickly comment on the more common one is typical is that like you don't really need to have an entire array of results. If you think about it, you only really need the previous number, right? Like
Yes.
whenever you're about to add to the array, don't add to the array. Just compare the previous value with the current value.
Okay. But then I gotta like pass in like the previous value, right?
Well, you don't need to pass anything. You can just sort over here, right? So imagine, right? So here you would just check, right? So if priv val is not how do this? I just like this, right? If it's there, then you just do compare. So um, if no.val is how does this work again? So this is we're always traversing increasing order. If no.val is less than priv val return false, right?
Oh, okay.
Else priv val equals no.val.
Oh, I see. Okay.
Right. So you don't really need to store the entire list when you traverse the array. You only need to know the previous number. That's all, right?
Yeah.
Yeah. So that would have brought your space down to be more efficient. Um,
Okay.
but it still wouldn't be O1, right? Because you would still have like you said, you would still have the stack and the call stack, right? And you were correct in that analysis in that so you were correct, but your wording was actually not quite correct. Like the answer was correct, which is that it's proportional to height of the tree. But I forgot how
Uh-huh.
you phrased it. But the way you phrased it made it sound ambiguous. No, it's not ambiguous. The call stack, or aka the space complexity, is always proportional exactly to the height of the tree. It's not, it doesn't depend if the tree is balanced or skewed. If it's skewed, the height of the tree increases, right? So it's always the height of the
Oh,
tree,
okay.
right? And so,
Yeah,
so,
I
so
guess I just like I was trying to say that like if it was unbalanced, then it would be like O of n, but it's like O of n would be the height of the tree. So yeah,
yes, yes,
I
that's
should
yeah.
have just said that.
So that's right, but the way you said it was correct, but not accurate, not precise, right? So, but I think
Okay,
it's correct
yeah.
the way you analyze it, right? If it's a balance, if it's a binary search tree, if it's a balanced binary search tree, then it'd be the height, which would be log of n, right? But if it's just any binary search tree, then it could be worst case O of n, which is what you said, which is what you wrote, but not exactly what you said. But otherwise, it was correct.
Okay, yeah.
Uh, okay, cool. Anything else before we wrap up?
Uh, no, not really. Do you have any like overall like feedback for me? Like, is it just like
Yeah,
the technical skills that I need to improve on?
I think the biggest one is just about practice, and not just doing more practice. What I mean by that is like when you're practicing on LeetCode or whatnot, like practice in the mindset of doing an interview, right? So what I mean by that is, of course, set yourself a timer, figure out what's going on there, right? So you have a time management kind of thing going on, right? Because that's something that people get lost on pretty easily. And the second thing
Hmm.
is don't use any help. Don't go online. Don't do anything, right? Just if you can't
Okay.
if you forget the syntax, too fucking bad. Do something else, right? Like most of the time,
Okay.
like you can't be caught up on that kind of stuff because that's not a crutch you can lean on. Um, you can't lean on that, right? If you don't know how the lambda keys work, you can't use it. Or what can I say, right?
Hmm.
So
Yeah.
so and that's just so it's not just that. It's also like, oh, I'm not sure the complexity. Well, too bad. Write it down. Write down what you think it should be, and then check it afterwards. Right? Don't like, oh, I'm not sure. Oh, let me just go search up the complexity of a DFS. No, no, no. Write it down. Like do what you do in a real interview, and then check it afterwards. Right? And then if it's wrong, then you should figure out, oh, why was it wrong? What did I forget to take into account? So what I'm
Mm,
getting is, I
okay,
think I
yeah,
think
that
the
makes
practice
sense.
is fine as is. I don't think you should increase the volume necessarily, but it's just that what you do when you do the practice is, can be changed as well. So just something to consider.
Okay, cool. Thanks. That helps.
Okay, take care.
Okay, thanks. See you.
Okay, we got one more guy. We got one more guy before resume review. So let me just get him on. Uh, okay. Um, yeah. So this guy had a question I wanted to answer as well before we get to the next person. How do interviewers make up their minds about a candidate? This is a pretty hard question to answer, kind of in like a couple minutes. But what I will say is we're typically brought in to evaluate a specific like let's say characteristic or aspect, right? So for example, previous interviewers would say, hey, this guy is very strong technically, not sure how good they are at collaborating, not sure how good they are at analysis, not sure if they're good at catching edge cases. Okay, then in that case, how I evaluate is I'll bring a question to the table that is aligned to testing those principles, and I'll see how they did on those, right? Sometimes I'm the open, like sometimes on the phone screener, sometimes I'm doing like the open interview, in which case, obviously, my goal is just to figure out what the next interviewer should test in more detail, right? So it's very dependent on like what stage you're in, what the interviewers are looking for specifically, and of course, sometimes a role has specific requirements, and we have to check for that, obviously. So it's very dependent. Anyways, hello,
Hello, how's it going?
how's it going? It's going good. How about you?
Not bad myself, not bad myself.
Okay, good to hear. Uh, Liko today, yeah. What's your language? Oh, you're a C++
Yeah.
guy, right? Or are you doing Python now? What are you?
Yeah. Used to be C++, but I took a few months to make the transition to Python.
Oh, so you're Python now.
Yeah, yeah,
Welcome,
because like
welcome.
after the last time you made some really good points about C++ and Python, so I was like, okay, maybe I should learn Python.
Wait, wasn't I the person who gave you also validate binary search tree or something? I gave you I
No,
get what did I give you?
I think you gave me like a graph problem, and constructing the graph took like a good
Ah,
while. Yeah,
yeah. I remember that. That was something related yeah. I remember. I do remember
yeah,
giving you a traversal problem and then seeing you struggle in C++. That was really something. So
yeah,
yeah. Okay,
yeah.
well, welcome to the correct side of the language wars. So that's good to see. I mean, jokes aside, I think it actually is a real investment that people should be making. It's going to
Mhm.
pay dividends the longer you use it. So
Yeah, that's
great.
fair. That's fair.
Now, I'm not prepared for this, so let me just see what we're going to be grilling you on today. We're doing intern hard. Okay. I see. All right. Any topics you're feeling like today?
Anything's fine.
Anything's fine.
Anything fun.
Anything
Anything
fun?
fun.
Anything
Yeah.
fun? Let me pull up my list of competitive programming questions. Let me see.
Oh no.
No, I'm kidding. I'm not. I'm just trying to open my lead code right now. Most of the problem,
That's
if it's
fair.
like a intern, easy, medium, hard, no problem. I got those.
Mm.
I got that shit backed up everywhere. But
Oh
sometimes I
my
want
lord.
to sometimes I just want to you know,
Hmm.
use a
No,
problem
that's
that's
fair.
not always yeah.
Hmm. That's fair. Yeah. Surprised if it's something that would appear on the interview.
I mean, I think most of the problems I asked don't really appear on common interviews because I feel like
Hmm.
if you want to just do interview problems, you do it in your own time. But
That's fair.
um,
Yeah.
okay, what is this? Okay, let's do a warm up. Let's start easy.
Hmm.
Okay,
Sure.
so let me take a look here. I mean, you know the drill, right?
Hmm.
You know the drill. You know how we do these sessions.
Hmm.
We got about an hour, right? 50 minutes or so. I mean, I think we've gotten some feedback already, so we don't need that much time for that. But we'll see
Hmm.
how it goes. Okay, so this
Okay.
problem is being called Tribonacci. Fibonacci. Now we got Tribonacci.
Uh-huh.
Okay, so it's we call the nth Tribonacci number, or we call it the nth number. Okay, so I want to write you a
Hmm.
function. It takes an n,
Hmm.
a number n, and you return the nth Tribonacci number.
Hmm.
Okay, so the Tribonacci number is very very similar to Fibonacci. Okay, but how it
Hmm.
works is the zeroth Fibonacci number is zero. The first number is one, and the second number is one.
Hmm.
And the third number, the n plus third number, is
Hmm.
the sum of the previous three, right? So instead of the
I
sum of the
see.
previous two, it's now the sum of the previous three. That's how the
I see.
Fibonacci numbers are defined. Okay,
I see.
so I want to write a function that returns the nth Fibonacci number.
I see. Sounds good. Um. Yeah, that sounds good. So this is pretty similar to like the classic Fibonacci number. So,
Hmm.
um, I guess I could approach it similar to how I would approach Fibonacci. Uh, I could first I just walk through like a quick brute force approach so that we could get the general understanding of it, and then we can start optimizing it
Yeah,
in any way.
yeah.
So yeah, so for this, the brute force approach is pretty simple and straightforward. What we could do is we could do the top-down approach. So well, given n, we could recursively call the function on n minus two, n minus one, and n minus three, I guess. And then I would just sum these three together um to get our current Fibonacci for n. And yeah, just the general gist of it. Uh, does it make sense so far?
Yeah, that makes sense so far. Yeah.
Yeah. Yeah. Yeah. So uh, so then there's a few problem with this approach. The first problem is that uh it's gonna use up a lot of memory for to create the call stack for the recursive function. Because from n, if we draw a tree out, we would have n minus 3 as one of the node, and n minus 2, and then n minus 1. And then from here, it would keep calling from n minus 6, and n minus 5, and n minus 4, and so on. And and some of the node, like say for example, n minus 5, it would appear twice in the left subtree as well as the middle subtree. So from n minus 2, we would have something called n minus 5 and n minus 4 and n minus 3. And we redoing like some of the computation here. So we're doing the computation for n minus 5 and n minus 4. Same thing for this n minus 5 and n minus 4 and n minus 3 as well. So these recomputation takes a lot of time. and it's gonna lead to at least exponential um, exponential time complexity. Um, so instead of that, what we could do is that we could save the computation for n minus 5 and n minus 4, for example, in like a hash map, and we could memorize it, right?
Hmm.
And that's gonna help us speed things up a lot. Does that make sense so far? Or am I going so a little bit too fast?
Oh, that makes sense. You're actually going too slow. No, I'm kidding. No, it's fine.
Okay. Sounds good. If that's the case, and then from there, I could do one more slide optimization on this, and instead of using like the recursion and doing top down, I could do like a bottom up approach and using the dynamic programming instead. So what I could do, like instead of storing like a hash map from the input to the output, I could just store an array, and I'll just start from uh, 0, 1, and 1, and then from these three, I'll just build up the array up to n, and then I'll return the last element. Uh, can I start coding on this?
Yeah, makes sense. Yeah, go ahead.
Okay, so I'll just call this Tribonacci, and yeah, I'll just do the third approach so that we don't have to go through like the previous inefficient ones. So what we have is that we're gonna initialize a DP array called DP, and we're gonna initialize the base case, so 0, 1, and 1. And from here, what we could do is that we could do a loop from 3 to the number n, and return to build up our solution space. So what you're gonna have is for I in the range of 3 up to n, and then so for this, what can I do? Oh, before that, I probably should initialize. Oh, sorry. Probably before this, I probably should initialize an array of size n first, and then I'll initialize the first three as 0, and then 1, 1, and this one's 1, 1, and 2. And yeah, and now for this, I could just do dp at I is equal to the sum of dp at I minus 3, dp at I minus 2, and dp at I minus 1. And this should do like a bottom-up approach. And at the end, I can just return dp minus 1. And this should return the solution. Do you want me to run through like a quick example on this, or
No, that's fine.
okay? Yeah.
Okay. Time and space, please.
Yeah. The time complexity would for this would be linear to our number n,
Okay.
because we're looping through it once, and then the space complexity would also be n. So yeah.
The space complexity is what, sorry?
The space complexity is n
Okay.
because we initialize an array of size n, right?
Yeah, that makes sense. Okay.
Mhm.
Okay, thank you. Let's go to the real problem then. Hopefully you feel warmed
That's good.
up. Okay, so this is a separate problem now. This is Alien Dictionary. Have you heard of Alien Dictionary?
Alien dictionary?
Yeah.
No, I've
Okay,
not
so
heard of
let's
it.
do this problem. Okay, so this is a bit of a prompt, so listen carefully. So
Mhm,
the goal here is basically to decipher an alien dictionary. Okay, so this is a foreign language. It uses a Latin alphabet. Okay,
mhm,
so A through Z, all lowercase. Okay,
mhm,
but the letters are scrambled, so don't mean the
mhm,
same thing.
mhm,
Okay, so your input is a list of words.
mhm,
Okay, it's a list of words. A word of obviously is a string. It's a string that contains some letters. Okay,
mhm, mhm,
and all of these words are already lexicographically sorted based on the aliens dictionary. Okay.
Mm-hmm.
And
Right.
so right, so that's the input, and and your goal is to derive the order of the letters in this language.
Oh,
So
okay.
so your output would be so your output would be just a string or a list of characters, whatever you prefer. That is the
Mm-hmm.
ordered list of it's an ordered list of the letters based on the other person's the alien language's lexicographical order.
Mm-hmm.
Okay.
I see. Uh-huh. That's cool. Wow. That's actually such a cool problem.
This problem is really famous, so I'm not sure if you did it already, but if you haven't done it, this would be a great test because I wouldn't say it's a popular
Mm-hmm.
problem, but there's a lot of problems based on this one.
Mm-hmm. Yeah. Yeah, I haven't done this problem yet. But it sounds like a really cool problem. Um, so uh so my initial question for this is that for the list of words, would it contain um would it contain all the characters in the alphabet? Like so that we would, like are we trying to produce the order for all the characters in the alphabet, or just like the ones that appear in the list of words?
Just the one that's just a set of characters that appears in the words. Yeah.
Okay.
So they
Cool.
might not contain all 26. It might just be like two letters, for example.
Mm-hmm.
Yeah.
Appear in list of words. I see. I see. Okay. Hmm. Okay. Um. So before talking about my approach, I think I'm gonna try and work out some example first so that I could understand it more.
Yeah, that's good. That's a good
So
idea.
yeah, so if I were given so the input is the ordered list according to the alien dictionary. Okay. So if I was given like car and then um car and then arc, for example. So if I was
Uh,
given car and arc.
car and art. Let me just think. Is that reasonable? That let me just think.
Mm-hmm.
Uh, so in your definition, you're basically saying that C is before A.
Mm-hmm.
Uh,
Oh, I
yeah.
see.
So I mean, yeah. This would be valid, but this wouldn't really be really helpful, right? I can explain another way that might be a bit easier,
Mm-hmm.
right? So let's say I have a
Okay.
list of words. A, B, C doesn't really matter, and these are variables, right? So let's do it this way.
Mm-hmm.
Word one, word two, word three, right?
Mm-hmm.
So your input equals sorted L words.
Right. Mm-hmm.
Alien.
Alien sorted.
Right. So
Okay.
when we sort it, right, it sorts words lexicographically, right? But this time
I
you're
see.
using an alien sort, which you don't know. You have
Mm-hmm.
to derive that, and then that's
I
your
see.
input. Okay.
I see.
Hopefully that makes more sense. Yeah.
Yeah, yeah. Yeah, that helps a lot. Mm, I'm trying to think of like in the easiest case right now, right? So like
Yeah.
if I all of all words are like one character, for example. So if we have like
Yeah.
B, C, A, and then D, for example,
Uh huh. Yeah.
then we immediately derive the order for this, right? Like, so it would just be B, C, A, D, S. Oh, so we're returning the order list of characters, right? Not words.
Yeah. We're a list of characters. That's right. Yeah.
I see. Okay. So yeah, so this would automatically determine um order already. So okay. So how would we be able to determine this? So if I was given um BAA, for example, and then I were given um ACC, so what would this tell us? We know that, so if we compare the first character only, then we would know that B is less than A. Um, then we would know B is less than. Okay, so Sorry, just to like do a quick backtrack
Yep.
here.
Okay.
So for lexical for lexical sorting,
Yeah.
we're comparing like the first character at first, and then if the first character is equal, we just move on to the next one,
That's
and
correct.
then so on, right?
That's correct.
So so that means that if we um I see, I see. So that means that if so given like a list of words, we're already able to determine some ordering to it already. So we
That's
would
right.
already know. So if we have BAA, ACC, and DDD, for example, we would already know that B is less than A, less than D. But then we don't know about C, right? Um,
That's right. You wouldn't know about C in this case.
right, I see. So given our list like that, would we be able to derive for everything? Would there be guaranteed a solution or just partial solution,
So
like in
that's
this case?
yeah. So it's correct that in this case you cannot identify C's order, but you can
Mm-hmm.
identify all the other orders. So in
Right.
this case, C you can put anywhere and it would be considered correct.
Ah, I see, I see.
So it has to be a
Okay.
valid, not necessarily the valid output. Yeah.
Ah, I see. Ooh, this definitely does sound hard. Let's see. What can we do with this information? Hmm. Hmm, what to do? Like right now, I'm thinking of like the most naive and brute force way that we could go about this is that we could just we could go through the first character of each word and then the second character and so on, and we can determine the order from there. And
Mm-hmm.
for any characters that's not um that hasn't been determined by the end of it, then we can just add it to the end of the list. Uh, so like any so and it would still be a valid solution. But
Yeah.
but yeah, if we were gonna do that, I feel like it's at the end of the day, I feel like it's also the only way to do it because I don't think there's a well, I mean, I shouldn't speak too soon, but I couldn't see if a way to more efficiently go about it. But yeah, so I guess I'll go through it. I'll go through it with the brute force way first, and then we can see if we can um if we can optimize it later. Is that okay?
That's fine. Yeah.
So okay, so what we're gonna do here is that so we're giving a list of words, order words, and this is gonna be a list of string. So what can we do here? So we said that we're gonna go through every single word and then every single character. So if that's the case, I'm gonna um if that's the case, I'm gonna have uh a counter to keep track of the current character index. So I'm gonna keep track of index 0, for example, and then for while the index is less than something. So what should it be? Um, do I have to find? Okay. So what I could do is that I could find the maximum length first. So for W in words, and then I'll find uh longest equal 0, and then I will do longest equal max of longest, and then length of W. And then so here I would find the longest length first. And then as long as the index is less than the longest length, I can just do this. For I in the range. So I'm gonna cycle through um every single position of the character to try and determine the order of the characters. Does that make sense so far?
Uh, yes, makes sense so far.
Okay. Okay, so how do I determine the order for this? Um, the easiest way I could go about this is that I keep track uh of like a hash set called scene, for example. So if I haven't seen this character,
Okay.
I could add it to my result, then add to results. And the reason why this would work is that we are going we're going through the list of words in order. So when we add it to the result itself, it's guaranteed to be in some relative order to our list of words, if that makes sense. So that would mean that if I say for example um at my uh uh let's see. Yeah, okay. So the order of this would be from character, so it would loop from character zero. Sorry, every single the first character of every single word in order, and then to the second character of every single word. So if it's seen in the sorry
Take your time.
yeah, so if it's seen in the sorry, let me backtrack it a little bit. I'm getting a little bit nervous. So so what would happen is that um if we go to the word from word zero to dot 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 word n, for example, this this would go from the lowest lexicographically to highest, right?
Yes.
And then we're gonna go from zero, like from the index zero to dot 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 to the index length longest as well. And this would ensure that we're checking the characters in like in order, right? So whatever we've seen before, so like since we're cycling through the list this way, so the list of all characters this way,
Yeah.
whatever we've seen before is guaranteed to be the lowest lexicographically because that's the order that we impose by just traversing through it. Does that make sense, or is it a bit confusing?
I want to challenge that. I think that's
Mm-hmm.
only true what you said if the
Mm-hmm.
previous. I think the second statement you're saying that's only true. Correct me if I'm wrong, I might not be understanding correctly, but this is only true if right. This is, I'd say this is if and only if the
Mm-hmm.
subset of char, so words, so word in from 0 to L. You can call this L, right? This is your length currently.
Mm-hmm.
Are all the same,
Yeah.
right? If
Mm-hmm.
the predecessor characters for your set of words is not the same, then you cannot make a claim about the current index character because it's not being sorted based on that character index, right? So if we have
Mm-hmm.
A B and then let's say Z A,
Mm-hmm.
right? So you can tell that A is less than Z, right?
Mm-hmm.
But you cannot say that B is less than A. Does that make sense?
Right. Okay. Mm-hmm. Yeah, that makes sense. Okay, that makes sense. Okay.
Okay, okay. Yeah, just clarifying that.
Mm-hmm.
Okay,
Okay,
continue.
that makes sense. That makes sense. But in this case, like we don't know about the order of B, right?
Yeah.
So so at the end of all this, can we just like I'm going with the assumption that if we can impose any order on B, for example, we can like if we can like have like a strict a strict rule for like for the characters. Like we don't have any concrete conclusion. Since we could just
Yes.
return any valid one, we can just
Yes.
say that it's yeah. We can just say it's less than. So yeah, I should have highlight that assumption more here.
Yes, you can put. So in this case, the answer would be like A, Z, and then B. Or you can be anywhere.
Mhm.
You can put B there. You can put B here. You can put B here. It doesn't
Yeah,
matter. But A has to be before
yeah,
Z in your answer. Yeah. Okay.
yeah. You're right. Yeah. So I should have highlight that assumption more. So like if we cannot impose a restriction on the character, we can just assume that it's we can just assume the some sort of level to it.
Okay. Yeah.
And yeah, okay. And and I think like like since we're doing it this way, like whatever assumption that we make, I want to make the claim that whatever assumption we make, it's still at the end gonna give us the correct the correct order, the valid order, the
Okay.
valid ordering.
Okay.
Yeah. Okay. So yeah, so like for the rest of this, I can just do like um I'll just iterate through every single word of it, and I would just check if the word has already been seen. So if okay, so I should have two of them. So I have seen. So this is my set, and this is my result of the ordering.
Okay.
So if it's in seen, then we can just continue, or else we can just add it to um or not the word itself, but the character here. And there's a slight caveat here. But if uh and then we can just append the character into our result and as well as the scene list. So add wi, and for this, as long as the I is less than length of w, and oh if sorry, wrong condition. If I is larger than or equal to the length of w, then we can skip it as well. Okay. Oh, yeah. And then at the end, we can just return the result. So yeah, that's what I have. Should I go through an example? So
I'm not. Yeah. Maybe go to example. I'm not convinced this condition is being met.
Mhm. Okay. So let's go through one example that we all have the same length and one we don't. So let's say we have A, B, Z, A, and then D, E, for example. So with the first iteration, we would have A, B, and then D, and oh not A, B, not A, Z, and then D, and
So
then
so
our second iter
this iteration, right?
yes,
Right.
yes.
So we're adding
So we got,
A, Z,
mhm,
and D. I agree. I agree. And then we add the three to
yeah,
the scene. I agree. Okay.
yeah, and then for
Okay.
our second one, we would have B, and since we don't know uh since since it hasn't appeared yet, so there's nothing that we could say about it. We can just assume that B is here, and
Okay.
then and we then it goes to E, right?
Okay. I think I see what you mean.
So,
Okay.
so, so that's what
Um.
we have right now.
Okay. Right. I'm trying to think of an example as well. Sorry.
Hmm.
Hard questions are hard to come up with examples. Okay. So what if? Okay. So I like this. Okay. So this is good. I want this.
Hmm.
Can you do this example, please?
Yeah. So A, B, Z, A, C, right? Oh, okay.
Yeah.
So this for our first iteration, we would have A and then Z, and then
Yeah.
okay, and then which is all is would only be A and Z. And for the second iteration, we would have uh B.
Okay.
Yeah,
Yeah. You would have B.
yeah, we have B, and then we have yeah, and that's the only one. And for the third one, we would have C. Oh, but they would not work.
Yeah. That wouldn't work.
I see.
Okay.
I see, I see, I see. Hmm. I see, I see. So if this was the case, so right now, like I feel like we make the assumption for B a little bit too soon, from what I could see as well. It's like the moment we don't know anything about, we already make assumption to it. But then again, hmm, I see, I see. Um, let's try and pivot from this then. Can we? What other thing I could do from this? Um,
I like the idea. I like the idea. I think instead of adding to the array immediately,
mm, mm,
we cannot at any iteration depth, you cannot know the absolute order, right? It's not possible because at a later depth that can refute your current order, right?
oh, you're right. Yeah,
So you cannot know that. However, what you
I see.
can know is you can know the relative order,
Mm-hmm.
right? So you
Right.
can always know the relative order at any depth. So, for
Mm-hmm.
example, for this problem, right? So you know that A is always less than Z, always less than that's true, but you don't know at
Mm-hmm.
this point if anything is less than A. It could be,
Right.
right? So instead of
Right.
saying A to Z is always one and two, how about you say
Mm,
that A is always less than Z, and you collect
mm-hmm.
a set of these relationships. So you collect
Like,
A to Z as a relationship. You collect
mm-hmm.
C to B as a relationship, right?
Mm-hmm.
So that would be your two relationships.
That makes sense. Okay, that makes sense. So oh, I see. So you, just just to repeat, so that I would understand here. So what you're saying that we can only say for certain that A is less than Z, right? But but we
Uh,
cannot say about anything else. Is that correct?
you can say for sure that A is less than Z, but you cannot
Okay,
say for sure that nothing is less than A. Because when you put it
right.
over here, you're saying that A is less than A is the smallest of them all. That's what you're saying.
Mm-hmm.
That's not
Okay,
necessarily true.
okay. Yeah, that makes sense. That makes sense. Okay, so if we were to have that then, mm-hmm. Okay, that makes a lot of sense. So we would have A less than Z, and then we would have, I guess in our example here, we'd have Z, B less than A, or
You wouldn't have
no,
that.
no, yeah, we wouldn't have this either.
You
So
wouldn't be able to
it's,
know that B is less than A in this context, because B is never compared
mm,
to A.
I see, I see. If we were gonna, mm-hmm, I see.
So in this
If we were gonna
example,
have,
sorry, I'll just
mm,
say. So from this example, the only thing you will be able to tell is A is less than Z and that C is less than B.
mm,
That's it.
and C is less than B. Okay, okay, makes sense. That makes sense. That makes sense. Um, so what does this tell us? Um, I guess from this uh from the examples we've gone through, I feel like the only way we could impose like certain we could impose we could conclude something certainly about something is if we have like this the common prefix, right? Because like this one we
Yes.
have the common prefix of ZA to ZA, right? So we would be able to compare the third one, C and B, right?
Yep.
And for the original one, the common prefix is it's empty. So if it's empty, then everything has a common prefix, so that we could compare the first character. Oh, so we compare the first character after common prefix. I see. And then we would be able to say something certain about them. I see, I see, I see. So I guess from there, from our new insight, what how can I pivot this? So if I were gonna do a if it was common prefix, um common prefix, I could let's just try something crazy. If we were gonna do like a tree prefix, right? We would have multiple trees. So this one would have ZA as a tree, and then we have node C and then D, and then we could compare these two, right? And our empty one would have um A and then Z. So yeah. What if we have another example of, let's say, A B Z A C Z A B, and then D E F D D A E, for example. So for this one, we would know that A and then Z and then B as the first one, and then for our prefix of ZA, we have C and D, and then for the other one, we have D, um, and then okay, I see, and then E and then A. Yeah, okay. So then from this we can construct everything else. Okay. Um, I'm not sure how uh, at this point, I'm still not too sure how to go from like a list of relationship and like
Okay.
this, and then construct it normally. Um,
Right. So there's kind of two prongs, right? So the first thing
mm,
is constructing the list of relationships from the given input.
mm, yeah,
Right. So in this
yeah,
case, from this input, you would produce A is less than Z,
mm,
C is less than D, and you would produce
yeah,
C is less than B, and E is less than A. Right.
that's correct.
And then from this set of relationships, you would then produce the
Mm,
final output,
yeah,
which is, I mean, in this case, an example could be EAZDCB,
mm,
right? So there's kind of two
mm,
problems here. Um,
mm,
I'll be frank, we only have time for one of these two sub problems. Which one would you rather solve?
mm. Um, I think I know how to. I think I get the general gist of how to solve for the relationship already.
Okay.
Like we could use like a dictionary, or we could also build our prefix tree from scratch.
Okay.
So is it okay if we solve the second set? Like
Okay.
the
Okay. Sure. So we
yeah.
can assume we have, I mean, you can represent it however you want. We can assume that we have that set of relationships. That's fine.
Hmm. Yeah. Okay. So if we were gonna assume that, so what can we do from this? This is actually such a good problem. Um, so we're gonna have E and then A and then A, Z, and G. Let's see. Hmm. At this point on, the only way, the only way that we could make any kind of conclusion about this is if they have something in common, right? So so in our case, since we have since this list and this list has the same character A, like it has something in common. That's how we could like join them together. So then we could join them together and we make E and then A, then Z and D, right? But for C and D, for these two, for example, they don't have
Yeah.
anything in common. So we can just combine them arbitrarily, right? And it would still be a valid solution, right? Then we would have E and A and then C and B, right? For example, or let's say we join this one and this one together first, and now we have this list. So now we can just combine arbitrarily with C and D, so then with C and D, and then this would be our final result. Does that make sense? But if that was the case, so we're trying to find intersection between the two lists, right? So say for example, if I have a oh, if I from my first list I have A, Z, and B and D, for example, and for my second list I have F, A, F, and then A, and then B, and then H, and then B, and then B, for example. So
Uh,
right now we have
sorry, could you explain how you got
um
the second list?
like it's just some arbitrary list, for example,
Okay,
right?
okay.
Like from our input, this is what we like from our input we
Yeah.
generate these two lists, for
Okay,
example,
okay,
right?
yeah.
Yeah, yeah. And then now we have two intersections, A and B and B. So what can we do with this? So we can so if we have intersection like that, we can only assert anything before A, for example. So then we would just have F and then A. But then for G and H and Z and B, it's also arbitrary, right? So
Yeah.
so then we would just we can just arbitrarily take some of these in and then just B and then D.
Yeah.
I Yeah, so I understand the general gist of it, but I'm
Okay.
not too sure what the approach that we could take here.
Okay.
Um,
Can we think about this in terms of a graph problem? So let's assume
as
that
a graph up.
each letter is a node.
Hmm.
Can you continue the thought from that?
Yeah. Uh, let's try it. Let's E, B, and D. And would they? I see. And would the two lists be connected?
So let's back up a bit. Um,
Hmm.
let's not worry about lists. Let's just think about every letter is a node,
Hmm.
and we have these relationships.
Hmm.
Wait, what are they? These ones, right?
Yeah.
How could you
Yeah.
represent relationships, ordered relationships?
We could do that by directed graph.
Okay, so yeah,
Um,
follow that. Keep going.
okay. So if we have directed graph, right? So we have A and then Z and then D. So this is what we what we would have, right? And then for this we would have um E and then we would have some E to A, for example. So there would be a
If it's easier, you can
um
use the drawing. You can use the drawing window on the left.
oh, I see. Um okay, I'm probably gonna use that then. So if we have A and then Z
Yeah,
and then D, right?
yeah.
And then if I have E here and I have A here.
Uh huh.
So if we so from this list we construct a graph and then we just traverse it. So if I just traverse starting from E, I would be able to get E is
You should probably write in the other one, other letters as well.
oh okay. And
So
then
you have
for this one
C,
I will have
you have C
C.
and B. Yeah.
Yeah. So so from our relationship, if we construct a graph, we would have some it's either connected graph or like there would be some disconnected component as well,
Yeah.
right?
Yeah.
So we would just pick the entry point of one first,
Okay.
and we just travel,
Okay.
right? We just travel and we keep traveling until we find all the characters. But but my question is like how do we know to pick uh E or because like right now like
Yeah.
because starting points right now
Uh huh.
could be either E or A,
Yeah.
right? Or C, right?
I mean, it could be any of them.
So
Right.
uh
like, it's just like in our case, it's E, A, and C, but it could be
yeah,
any in reality. Yeah. What's the algorithm called to solve this exact problem?
what's the algorithm called to solve this exact problem? To find the entry point?
That's part of the algorithm. Yeah. Or in other words, if you look at E and C, what is a
Mhm.
characteristic about these two nodes in the graph that no other node shares? Only E and C share this property, no other nodes share this property.
Oh, right. It doesn't have was it the in degree, right? It's in
Yes,
degree is 0.
correct.
Ah, I see. So I guess that from our list of relationship like this, we would be able to like to calculate the in degree. And then from there we would be able to pick the starting point, and then we would be able to traverse it, and then determine the order. Ah, I see. I see.
Cool.
That's cool.
All right.
That's actually such a cool problem.
Yep, it's a good one.
I like.
I recommend you actually go solve it for real afterwards.
Yeah, yeah, definitely. Is it on legal?
It should be. I think it might be a
That's
premium
a pretty
problem,
cool problem.
but it's just
Mm,
called Alien Dictionary. I was like, this is the exact problem. I didn't change it at all. I was too lazy
mm,
to change it. There is a
that's
harder
fine.
variant, but then there's also an easier variant
Mm,
too.
I
But
see.
anyways, okay, so let's
Mm,
call it here.
mm,
Obviously we're a bit low on time, so and I mean, like, at the end it became very theoretical. I'm not gonna actually make you write anything, obviously, but yeah,
mm,
this problem is a bit harder than the usual ones you'll see. Even for a hard, it's definitely not easy.
mm.
And that's also partially because the abstraction of a graph is so far removed from what you might originally think of. But I
Yeah.
mean, let's just start this off. How I usually do is like, what do you feel? How do you feel? How do you feel like you did? There were two problems, right? So about each one.
Mm, yeah. Um. Yeah. For the Tribonacci one, it was pretty standard, so I don't have a lot of thoughts on it. But
Yep.
for the second one, um, I feel like for my
Real quick before
initial
we move
thought.
on, we'll talk about the
Uh,
second one. Were you aware that your Tribonacci was not optimal?
sorry.
Are you aware that your Tribonacci is not optimal?
Yeah. There's also a way with like just only three variable, right?
Yeah.
Yeah, because I was like, should I talk about it? Because I seem like I keep talking about like from the brute force approach all the way to DP,
Yeah.
and because like I could not do DP without going through the brute force way
Yeah.
first. So I feel like I was taking a little bit too much time, so I didn't
That's
I
fine.
didn't care about it. Yeah.
No, that's fine. That's fine. It makes sense. One more thing I will say, I mean, just as a tip for general interviewing, is
Uh,
you explain the problem top down,
mm,
right? And that's fine. But do note that, like, if you're gonna spend a lot of time explaining top down, it might be a bit of a surprise to see it you then code bottom up. So like,
yeah.
just be aware, like, yeah, like, and I will say, like, okay, for a problem like this at a company that you're
Mm,
interviewing for, you don't need to explain it in that much detail. I think the way you should
right.
ask is like, hey, do you want me to explain this in more detail? Is this level of detail sufficient? Do you want to move on? So just check in more
Right.
often to see if that's needed or not, because if they're asking
I
you
see.
this, it's probably either a warm up or this is a one of many questions that are following up. So just be aware of that.
Fair enough.
And I will
But
say that, like,
mhm.
go ahead.
Sorry, go. Oh, I was just gonna ask, like if you were given something like this, right? Like,
Yeah,
like, because for me, like, I couldn't do DP without going through all the brute force. So,
sure.
like, should I even try to like, should I learn a way to like do DP without going through the brute force first, or like,
No, it's
it's
fine.
like, I feel
If
like,
you need it, if you need the brute force to do DP, that's fine. You can do it, but just be aware that
mm,
you might not need to explain in that much detail because that does cost you a bit of
mm,
time. I will also
I
say,
see, I
like,
see.
okay, this is Python, and depending on the interviewer, they might not let you do this. But the first thing you said was actually you can memorize using a hash map, right? I think that's all you said,
Mm,
and
right.
you could still do it that way, right? So,
Oh,
and that would be and
that's
now
fair.
in terms of efficiency would be comparable. Now, the DP is
Mm,
still better in terms of space complexity if you optimize the the space. But the way I have it written right now with O in
mm,
space, it's the same complexity
mm,
between this and a recursive solution with
that's
memorization,
fair.
right? So
That's fair.
just be aware of
Yeah.
that. And
Mm.
now you're obviously in Python land, so welcome to Python, right? But you can just cache it.
Yeah. You sound so
Right.
excited.
Right. So cache it. Don't worry about using a hash map. You can explain that if needed. Right. In reality, you're just
Mm,
never going to see this problem in a real interview because it's just too easy. Anyways, moving on.
that's
Alien Dictionary. How do you feel about the difficulty? First of all.
the difficulty is it's very how do you say it, like conceiving, like it's very deceiving. I mean, like, it's
Okay.
like like originally I thought it wasn't too bad of a problem,
Yeah.
but then it's because I made too much of an assumption when I go through this, right? And I fail to realize about
Yeah.
like the prefix and so on. So if I were able to like if I make the assumption and realize the prefix right off the bat, I feel like that would be a really big plus. But yeah,
Yeah, that's part of the part of the trick of the question, right? Like that's why it's a hard.
that's fair.
Right. So, but what I will say is, right. That's the easier version is that
Hmm.
the words are sort of lexicographically the same as here,
Hmm.
but each word, like within a word, they're also sorted lexicographically, right? In
Ah,
that case, you don't need to worry about the prefix, but in this case, you
right,
do, right?
right.
So what?
I
But why
see.
is that important? That's important because that disqualifies questions, solutions like naive loop, right? Like,
Hmm.
and I would say, I mean, this is hard to say, obviously, especially in hindsight, but
Hmm.
like, this is why it's important to make good test cases, right? Because
That's
if you
true.
had a good test case, you would have caught that, right? And I
That's
will say,
true.
and that's not easy. Like even like I knew that you had the bug, and I still took like a couple seconds to figure out a valid test case for you,
Hmm.
right? So be
Right,
aware, like that's why it's hard. That's why it's here, right?
right.
So
That's true.
generally speaking, if especially if the question you don't really know what's going on, like you need to walk through some more
Hmm.
tests, make some good tests, right? Make some tests that cover
Hmm.
more cases. So
Yeah,
so you might not you
that's
might be able
fair.
to avoid that, avoid that situation.
That's fair. Yeah, because the thing about like I knew that there was something wrong with it, but I couldn't really voice it in my head, and because like
Yeah.
I was talking continuously, like it's a little bit hard to like come up with test cases and then keep talking at the same time. But yeah,
Yes. Yes.
I see what you mean. Yeah. For Leo, for a question like this, like for the hard one, like usually like they from what I've heard, like usually you need to like either do them before to see the trick, like there's like some kind of trick that you need to see to be able to solve it. So like how do you get used to like seeing these tricks, or like do you just have to do more
Yeah.
to know more about
I'll be honest with you, right? So things are only tricks if you don't understand what's going on,
it?
right? Like I'll give you. So I was asked this question before, and I'll tell you what I was thinking. I didn't see this problem before either, right? The
Mm-hmm.
first thing that I realized was that the question is intentionally confusing by using random letters, right? Well, let's just assume the aliens have the same alphabet, right? Like why are we
Right,
confusing ourselves, right? So the
right.
first thing is like, okay, how do we simplify the problem space and not be like humongous, right? It's all about
Mm-hmm.
controlling your mind share. The second thing I'll say that was really obvious then general is, do you actually understand how sorting works, right? Do you understand how
Mm-hmm.
sorting works? If you understand how comparing a set of words or characters or whatever it is works, and the reason
Right.
that's important is because comparing letters is essentially like you compare them one by one. You compare any two letters at the same time. But when you make a
Mm-hmm.
comparison, you're actually drawing a relationship, right?
Mm-hmm.
If you think about
I
the
see.
implementation of a sorting algorithm, every time it
Mm-hmm.
makes a comparison, it's referencing some source of truth, right?
Mm-hmm.
The source of truth for a real sorting algorithm is by looking at the ASCII index of the character, right?
Right,
But we
right.
define it ahead of time, right? And so
Mm-hmm.
to solve this problem, we need to define that ahead of time. Like we need to figure out what the definition is, right? So immediately
Ah,
the intuition here is not what trick is there. No. Like this is how sorting works. The way sort works is that there is a predefined order for all possible inputs. That has to be,
ah,
right? And so you just need to generate that, that encoding,
I
right?
see.
That's how that works. So the quote unquote trick in this case is simply just figuring out what the encoding is. And how do you figure
Mm-hmm.
out encoding? Encodings for all relativity is that usually, like I said, it could just be a list, or it could be absolutely ordered. That's what it's called. It's called absolute order, where everything is
Mm-hmm.
perfectly ordered relative to everything else. However,
Right.
this problem states that you might not have perfect information. You might not be able to determine an absolute order. Therefore,
Mm-hmm.
you can't use a list. Therefore, you must use a graph.
I see.
So that's not a trick. That's just a property of how ordering works. If you don't have an absolute order in the universe, you must use a graph. That's
Mm-hmm.
just how it works, right? And so, okay, we have a
Right.
graph. We define the relationships as such, and you drew this, right? So you drew this very beautiful picture. Where the hell did it go? Here it is,
Mm-hmm.
right? And then we just need to figure out, okay, so we have components of a graph, right?
Mm-hmm.
All the nodes with or all the letters within a component are ordered, but the components are not relatively ordered. So
Right.
therefore, and this I literally said, what is this? This is just topological sort, right? This is just topological
I
sort.
see.
So you generate the encodings from the relative embeddings in the letters, and then in the words from the letters, and then you just do a topo sort on the graph, and that's your answer.
I see. I see. Huh. That's actually so interesting. That's really cool. Yeah.
Yeah, I mean,
You know,
don't.
mhm. Sorry, I was just gonna say I actually don't know about like topological sorting, so that's why when you asked me about like what's the algorithm, I don't know.
Okay,
I didn't
well,
know which one to.
I
Yeah.
see. Well, you can go study that later. You can go study topological
Yeah.
sort.
Yeah.
Yeah,
Yeah. Definitely.
I'll also say that
Yeah.
I mean the tree solution would be pretty good. Like that's definitely one of the ways you can generate the encodings. I'd say for this
Uh,
kind of thing, especially if it's a hard, you don't know the answer, don't
mm,
focus on efficiency. Just write something down. But the
mhm.
difference between hards and mediums is that for hards, you can't write the brute force algorithm. That's just it won't even be close, right? Brute
Mhm.
force is this one. What is it? 26 factorial. Not gonna work. So so
Fair.
but if you have a solution like, oh, a tree could work, just immediately start writing it. Like stop wasting time, right? Now in this
Mm,
case you're out of time, so we just talk about it. But in a real solution, that's what I would expect you to do.
sounds good. Sounds good. Right. Thank you so much.
Great.
That
I mean,
was
hey, look,
that's actually so cool.
don't feel bad about this. It's a hard problem for a reason, but I think you still made good progress, and there's a lot for you to learn. So I mean, I think you did well overall. Good stuff.
Thank you. I think I did much better than the last time you gave me a hard question, so I'm pretty proud.
What was the last one I gave you?
Yeah. Uh, oh, I cannot remember. I think it was related to something with uh damn it, what was it called again? Union find. I think it was something related to Union find.
Oh,
I was just so
I
bad.
gave you the prime jumping search. I gave you the prime factor jumping
Yeah, yeah, oh
search.
yeah, yeah, that
Okay,
one, that
okay.
one.
Yeah.
Uh,
Yeah. That one's. I'd say this one is a bit harder than that one, but it's different. It's completely different sets of knowledge and skill.
that's fine.
So.
Yeah, that's true.
Yeah. Anyways, okay. Yeah. Thanks for today. Yeah. I mean, thanks for coming on. That was good. Take care.
Thank you so much. That was
Yeah.
really fun.
Yeah. You're welcome. All right. Yeah. Leet code hard alien dictionary. I think this person's actually pretty decent, so that's why I asked them this one. But generally speaking, you shouldn't expect alien dictionary type problems in your interviews. Okay, let me get set up for the resume review. I think that event's starting out. Yeah, okay, great. So we're gonna just hit this up. Let me get myself set up. Boom. What's going on in the comments? Let's have a whole bunch of comments going on there. I didn't catch them all, but I think Eric's actually answered all of them. We have a new one. I heard some interviewers are cool with Googling syntax since that's something you might routinely do on the job in reference to lambda sort keeps on the last interview. What's your thoughts on this? Doesn't hurt to ask. Doesn't hurt to ask. Never hurts to ask. The context I was talking to that previous participant about was, if it's like a role that's expecting Python knowledge, and you don't know it, like yeah, you would search on a job, but we're not testing your search skills. We want to test how well you can mitigate some other aspect, right? So in this context, you forgot the syntax, right? In another context, you might forget some other thing you don't know how to search, right? So it's about problem solving, not search skills, right? Like I'm that's a it's a different skill that's actually being tested on. Practicality speaking, right, from a practical perspective, yeah, you should ask, hey, I forgot this, and I think this is how I would do it. I'm not sure this is right, and this is what the candidate asked, right? They say, oh, I'm not sure what it is, but in this case, I want them to actually solve the problem and not just use like a memorized solution. So that's why I told them to actually figure it out otherwise. But it doesn't hurt to ask. People won't look down on you for that. Okay, so. Okay, let's see. Where the hell am I? I am on the wrong slide. That is not a calendar. This is a calendar. Okay. So, where's review? Here's review. Get rid of that. Okay. All right. Today's date is 1. No, it's 2 already. Oh, shit. 2. So we have some submissions. Okay. Start. Okay. All right, so let's see what's going on here. So this person submitted 3 resumes to look at. Let's have a look. So this one is made changes. I guess still have some improvement. This version is targeting ML or data science. I know they're not the same, but from a lot of job postings I've seen, I feel this resume could fit for both. Looking for internships. Okay. Didn't take up the software projects, as I've also seen these jobs mention some level of software skill. Please let me know if project experience might be best to be taken out. Since I already have 1 internship experience. Also, is the ML bullet points better, less gauge? Better slash less gauge. Okay. They are old products, so I summarize them better. Okay. Regarding additional work experience, I included them because I wanted to show 3 years of work experience, and I figured it's our 2 why not put it there. I guess we remove the software product area. There might be hope to do 1 sentence summarization. Thank you for the help. Okay. Let's have a look. Let's have a look. Let's have a look. What color should we use? Let's use like a green color, like kind of like this. Yeah. Okay. So yeah. So first of all, 2 pages. But this person, you can see they have had about 3 years of work experience previously in a different kind of career. So we'll see what's going on with that. Okay, technical skills. Right. That's okay. So this is MLDS, right? MLDS. Keep that in mind. One thing I will say is that it might make sense to put some MLDS stuff over here. Like, yeah, Python, that's good. Tools, you have Jupyter Notebook, which is good. What else do you have? Do you have like SciPy, anything? Yeah, not too sure. Okay. This I saw already last time. Not in comment on that. I think it's fine. Like again, you said you want to keep the work experience there. I think it's okay to put in. These make sense. What I will say is that one thing is that if you're going 2 pages anyways, like okay, this is fine. But if you wanted to go 1 page, I would pick one of these 2 to focus on, right? Okay, so the book 2021. Okay, that's fine. Which one do you think is more impressive? That's the answer, right? I will say like okay, so what's the skill being demonstrated? So you're saying this is what this is K means. K this is K means this is K means and KNN. These are like these don't need to be 2 separate points in my opinion. Neural network developed. Okay. And what is this? This is it naive Nas. Okay. So the first one definitely seems more impressive to me. The second one feels a bit flat compared to the first one because like K means KNN, and you have a neural network, but yeah, and a neural network here, which is good. Okay, you have an MSC. Without weather, with weather. Okay. Let me see. Okay. Yeah. Okay. I feel like this point over here is redundant with this. Is that the same thing? But anyways, I feel like yeah, both of these you could probably cut down between these 2 experiences. If you have 1 point, save a bit of space on that. 1 or 2 points maybe. But the overall question was still, if you're on 2 pages anyways, keep them in. Yeah, I'd say so. If you're on 2 pages anyways, keep it in. I'd say the order. I'd say that if you're on 2 pages, the most important thing is obviously the ordering, right? So what do you want the human to see first? That's what I would say is the more important part. So yeah, if it was a human, I would probably put the education at the bottom. At this point, you have so much stuff. Or you can keep. I mean, it's a toss up. I say the ordering either put the education at the bottom or keep it as here. Keep putting it at the bottom of at the bottom of the first page at a page divide is kind of diabolical. I won't lie. So either put it at the bottom or put it at the top. Sorry, like either keep it here or put it at the bottom. I'd say you could go either way on this one, honestly. I'd say you can go either way on this one, but I would probably move it down if you're not gonna put this piece, at least this piece at the top. Right, your current education, that makes sense to put at the top if you're a student. These things, I mean, these are a bit more suspect in terms of usefulness. So you can maybe split it down, like alternate, like you could put this on the top and put this up under a separate heading, like other education, something like that. Yeah, I would also say, okay, putting this at the bottom is not worth it if you're putting technical skills at the top. So definitely move the skills down. That's what I would say overall. Okay, this is a separate version of the resume. Okay, this is a separate version of resume. This is meant for, what the hell is J25 open? This is meant for smaller companies. Okay, makes sense. Let's take a look. So the difference, yeah, that makes sense. Okay, work experience. Okay, so again, I would say the same thing. So in this case, you should put the education and the technical skills. I would swap those two. Especially because smaller companies, they won't be looking at the specific skills as much, and they will be caring about local things like your university education. Otherwise, these are the same points, yeah? Yeah, the same points as... Oh, no, I think these are improved from last time, actually. Let me see. That's fine, that's fine. Yeah, a bit of Figma's good. That's fine, yeah. And these are the same as... Okay, yeah. Oh, this is the expanded one, okay. Okay, for small local ones, yeah, this is what you said. This is fine now. Go with that. I would say stop optimizing... I wouldn't say just optimize for that, but I think the way you phrased the small ones, I think that one's okay now. Okay, and this is the one which you're focusing on for. This is for big tech. Okay, so this is the one I'll spend a bit more time on. Let's take a look at what's going on here. Okay, so education, that's fine, that's good. Skills, that's fine. Okay, so. Yeah, skills, education, you can always swap these two, up to you. I wouldn't say it's a big deal. It's fine as is. That's all the same. Okay. Are these the same points as this one, I think? Yeah. I think these points are fine now. Projects, let's say, so this is... This is okay. So this has been going on for a little while now. Developing a full. Okay. This is okay. This is lacking technical detail, right? So that's fine, but I'll need to see what the space is being used on. Okay, this is fine. This is UI UX, right? This is UI UX. Do you have UI UX stuff in this experience? I say cut that down to one line if you can. Feed from Eric. I personally cut the non-ML product from the second page. Even from this one. There was two, right? There was an ML resume. That's fine. As long as the ML stuff is front and center, I think that one's okay, because at least you can at least you can, if a human reads it, they'll see the important stuff first. This is for smaller companies. Oh, extremes behind. Okay, yeah, no worries. Yeah, I'd say that's actually a fair criticism. I mean, you can definitely, I would say, yeah, like you can cut these two out, because you have these already, and just use this and just into this experience to demonstrate, like technical competency. That's fine, but just cutting that out wouldn't say this. I mean, it would still be on 2 pages. So, up to you to leave it in or not. I think as long as, like, for these kind of things, if you want to put this much stuff on, it's okay, but as long as the front and center stuff on the first page, that has to be complete. Back to this one. Yeah, I can cut this on a one line. Oh, different green. Clearly, okay. This is QA stuff. Okay, so this is okay. Okay, this is a good point, but it's not that relevant for big tech. Okay, this is good. But at least I would say just buy. Session scale product. scalable product analytics practice to track user behaviors and improve client retention. This is okay, but this doesn't contribute to your software story, right? Automated user processing workflow with Python. This is good. This is good. I said these points you should either get rid of them or rephrase them, or or do something about it. It's taking up space and it doesn't contribute to technical competency. I think otherwise this resume is decent. Let's say, should project points be as detailed as experience points? Yeah, absolutely. In fact, I would say project points should be as detailed, even more detailed, because you actually have the ability to find out the details. But in reality, they should be. I mean, if you're trying to portray a specific thing you're good at, it should be detailed. If you're trying to save space and just communicate in broad strokes, then they shouldn't be detailed. But if you're asking, like, can they be detailed? Yes, they absolutely could. Eric, maybe keep like one of the full stack projects. Yeah, I mean this one you can keep one of them. This second one is a hackathon. I think the way it's written right now, if you're on 2 pages, just keep them both, man. It's fine. If you're trying to cut down to 1 page, then yeah, cut out these 2 products, I would say, and just use your current experience for to show general software competency. Okay. Okay, moving on. Let's see. So that was good. So this is the start. Get rid of that. Okay, we have one here. Okay. So this person's comment. My most recent internship was a technical support SRE. Want to pivot to Sui. My products are mostly full stack. Want to go back in dev. Okay. Back in dev will accept any generalist Sui. Okay. Makes sense. Let's take a look. It's fine. Okay. Ooh. I would say these 2 aren't that relevant for what are you? You are what's your education? Okay. So you're getting to 3rd year now. I'd say these 2 aren't relevant anymore. Okay. SAP. Okay, also this blue. The blue's a bit weird, I won't lie. Like this blue for projects, for linking makes sense. The other blue doesn't really make sense. Okay. 100% enterprise, 100% satisfaction. Okay. Okay. Develop strong to database administration task performance tuning per run. Okay. 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 That's fine. Top level comment, too much bolding. I'd say cut it in half. Okay. This is a TA, proof and discrete math. Okay. One-on-one guidance, okay. 3 points for that. Okay. We'll see if we can cut that down. 3 points for, like, I'll be like second thing, right? Second experience. 3 points for that already. I don't know, man. Okay, let's take a look. This is recent. These are a while ago now. Okay. Let's take a look. A scalable full stack app, MEC architecture data set pro. Okay. So scalable is a descriptive word. Yeah, it's not been proven yet, but let's take a look. Implement TypeScript promise to handle 64,000. Okay. Reducing. Okay. This is an English thing. Okay. Reducing API response time by 80%. From what? From non-asynchronous, from JavaScript, from JNux. So right, reducing. It's not like it's if you're providing a relative measure, you have to have an absolute measure to compare it against. So this is not. I like the idea here, but the wording is actually just incorrect from an English perspective. Improve code quality or hedging code. Okay. That's not a point. I'm sorry. That's not really a point. Weekly Scrum meetings. 3.0. Okay. To the read. Okay. Okay. For a project, having project management stuff, it just doesn't really make sense, to be honest with you. Like, there's a lot more you can be talking about here, I think. For example, talk about the backend, right? Like, talk about what's going on. I mean, first of all, what is the backend here? Is it a node? What's going on? I actually don't see what the backend is. Talk about the backend. So right now there's nothing about back. Like, okay, you have this thing, but this is the only point you made, right? Talk about some more. Like, this is not like I think this is lacking a lot of technical detail here, frankly. Otherwise, otherwise it's not gonna sit too well. What I will say as well, right, is that like you're from UBC, right? Like, you know these. Wait, you are, right? Yeah, you're from UBC, right? So you should know these things, okay? When I look at people's UBC resumes, the first thing I check is, where's the 310 project? Okay, so how are you going to stand out against other people's 310 projects? That's what I'm getting at, right? So you take that however you want, realize that there might be an issue there, okay? All right, what's this? Social media finder, account finder. Okay, interesting. Oh, okay, so a bit of back in here. Full stack web app, open search. Okay, using open source script to okay, never mind. Open source script to search for social media handles across your networks. Multiple server, Lizzie reducer. Okay, post request. Okay, see, compare to, right? So this is anchored. Okay, this makes sense. Now that's a very high number, so a bit of doubt, but I won't doubt it too much. Closer time to hunt down pre-warm. Okay, this is good. CSC, this is also good. So this is quite good, right? It's very DevOps heavy. A bit of performance talked about here, but I think this is a better. This one makes more sense. Right, but of course this one, of course, the obvious one is that there's no front end, right? Like, you haven't talked about the front end at all. So, it's like there's a bit of a conception over here for front end, integration, but I think that's fine. Focus on the back end that makes sense. But the first one's definitely a bit more lacking. Okay, see with this one. Electric vehicle test bench. Firmware C++. Okay. Wait, what's this? Enhanced dashboard. Oh, this is a dashboard, not okay. Improved driver approval, new data focus on design. Interactive. Okay, I see. Design chart. Okay, I see. This is fine, but this is the data here is not here nor there, right? Like, this is kind of like what am I supposed to get out of this? I can't tell your C++ skill from this. There's no detail there at all. You've done some UI stuff. There's no library you mentioned, but you've done some UI stuff for a HUDs. You use Grafana, and you said that your UI is interactive, right? So this is very, very watery. There's no information to go off of here, right? So this is it's not quite there either, I'd say. Leadership curricular, blah blah. Okay, that's fine. Yeah, I'd say this is definitely the strongest one so far. Add some more data points here if you can. This 3 points is honestly okay. I think compared to other stuff here, this 3 points, keep it there. That's fine. First one, you definitely need to expand more upon why it's scalable. What's going on with that? The back end needs just generally more description on this one. This is entirely back end. Makes sense. It's a bit of DevOps here too. That's nice to have a bit of DevOps. But it's also a bit light on information. The third one here, frankly, I'm not sure what this is trying to. If you're going for firmware roles, this resume is not geared quite right. If you're going for generalist suite, this doesn't provide any value. Frankly, I think you can rephrase it perhaps. Talk about like collaboration. Yeah, like you talk about having stakeholders, like non-technical stakeholders. That could make sense, right? Like for example, like say stuff like I've improved approval by 50%. Doesn't really mean much because it's not like that's more of a qualitative thing, right? Like, it's something. Is this a CSAT score? Like, what's going on here, right? So, like, data points, like for the sake of data points, don't actually add any data, right? Definitely a bit more work to be done there, but let's go on. Let's see. Okay, next one. Hey, what's going on here? Am I tripping? What's going on? 2 people uploaded the same resume? Yeah, two people sent out upload the same resume. That's crazy. All right, whoever. I mean, well, I can't review it. It's the same fucking resume. Different comment though. Different user as well. Wait, is it actually a different user? Oh, I don't record email, so I can't see. But okay, whatever. Moving on. Okay, so this. Let's take a look. Okay, this looks fine. That's whack. Agree too much welding. I've heard some recruiters actually say they like seeing technical skills bolded, but this goes beyond that. Yeah, I think it's definitely useful to have it bolded, but I would say it's also a fine line, right? Like if you bold every technical skill, it's also way over. If you bold things that aren't relevant to be bolded, you're just eating your bold budget. That's not really good either. I'd say if all else are equal, right, lean on the side of bolding less. That's how you can actually make sure the things you bold are actually seen. So that's where I would that's what I would say about that. Okay, anyways, this guy says, hey, you reviewed my resume a couple times for last year. Says, all right, looking to see if anything to say now. Make some changes here, like interviews, not getting anything. Okay, I plan things since they come out. Even writing cover letters for companies like SAP, Total Framework, to write colors. Okay. Okay, so this is good information. So you're saying you're applying to companies like SAP. Okay, I got it. Got it. Yeah. Sometimes though it is just gonna be hard. That's how things are sometimes. Okay, let's take a look. Okay, that's fine. Okay, so we have a piece of work synthesis last year, some technical stuff. Okay, skills at the bottom. This is fine. Lowercase s, very good. Okay. Chat servicing 30% developing Docker containerized. Bidirectional streaming for communication. Okay. Okay, I'm assuming this. So you're saying reduce by 30%. Is this from a previous non-containerized Go, or is it containerized not Go? Was it using containerized Go but not using gRPC? So a bit of again, right? It's a relative thing. Relative to what? Same thing over here, but it's okay. This one makes more sense because that's you built it, so previous to not having this React dashboard. Right? So this one makes sense. Showing the customer interaction, WhatsApp, NLP models. Actually, okay, that's good. Okay, that's fine. This is a while ago. Okay. Not too far, a little while. IDR frame rate. Okay. Okay. No, this makes sense. This is good. Typing game with player. Okay. Oh, yeah, I remember this one. Yeah. Real-time like service. Elevated UX. Elevated user journey. Okay, that makes sense. Okay, great. Nice. Oh, double lowercase. That's rare. Oh, it's OpenCV, media pipe, grid search. Okay, a lot of stuff going on here. Wait, what is this? Gradient boosting classifier, grid search CV. Okay. Precision scores 9%. Okay. I like that. Skeleton view enhanced. Okay. That makes sense. That's fine. Enhanced UX by print out real-time feedback. Okay. Well. Okay. What is this? It had to provide real-time feedback on lifting form. Oh, weightlifting. I'm like, why are you like? What's going on with these fucking? I thought this was like submission form. Okay. I see. That's what this was. Okay, no, that's my reading issue. That's my fault. Trying to communicate consumption schedules. Okay. Get out of this point, man. Okay, so I'd say projects so far. These two are kind of the main ones. What is your note? What is your note? Your note is no note. So it's full. So just any SD. Okay. So these two projects provide much less value than these two projects in terms of just general SDE, right? And so if you have more data that you want to share about these two, put them in, right? Put them in. Sacrifice these two if you need. These two are really they're good for what it's accomplishing, but they don't provide more value in terms of SDE roles. So I would say if you have more stuff here, definitely put it in for the first two projects. That's I think is the main piece of feedback. But overall, I still think the resume is still decent. I don't think there's anything that you should be like drastically overhauling here. frankly, a lot of it is just gonna be a numbers game, and unfortunately, I've seen people with strong resumes just not get luck. So don't take that necessarily as a sign that your resume's not good, but just a sign of like the market's not doing too well, or you're not getting the kind of hits that you want. I'd say at this point, yeah, volume for applications is going to be the name of the game. Hey, that's my resume. By the way, more feedback I got from other people is that it's too clampy and just too dense. I definitely do not think this is too dense. I think this is about right for the technical kind of things. I think maybe some people, if you see like a swath of resumes that are like more junior, they're gonna seem less dense. But I would say, I would say more often than not, you don't need to worry about things being too dense, because density typically means that you have things to say. And so if it's not dense for the sake of just being dense, like if you're just adding adjectives and just random ass statistics, yeah, okay, that would be bad. But everything you have here so far actually makes sense in terms of like what you had. So I think it's fine as is. Okay. What's going on, chat? Sounds good. I always wanted to get rid of the Java product and design team, so adding that stuff. Not time soon. Looking to do a lot. Okay, yeah, I think the Java product's pretty weak compared to the other three. So I'd say you can definitely get rid of that. Part of design team, yeah. Design team stuff is cool to put in. You can put it in after. Who's this guy? Bro, no one wants me. Haha. I don't know what this guy said. If you delete your comment, okay. Don't say whack shit, okay? You say whack shit, you get 0 warning, you're banned. I don't care. It's my fucking chat. Okay, let's move on. Okay, this guy. This is a different guy? What's this guy? Let's take a look. Yeah, it looks good. Oh, was that guy saying whack shit? If that guy was saying whack shit, Eric, tell me. I'm banning that guy on the spot. I literally don't care. Alright. So this guy's comment is, okay. I want to allow new grad suite offer leading towards backend. Okay, gotcha. What's your locality? Whenever someone says back and I have to check the locality, Vancouver. Got it. Okay, let's take a look. Blah blah blah. That's good. Education. CSC. Okay. Don't do these vertical bars things. Don't like the pipes. Don't like. To be frank, no one's parsing these in the first place. But generally speaking, don't use pipes. Those aren't parsed very cleanly. Okay, let's see what you got. Cloud computer. Okay, that's fine. You can keep that in. I will allow it. What's going on here? Put the languages first. Blah blah. That's Erlang enjoyer. Oh, Scala enjoyer. Oh, cultured individual. Okay. Let's take a look. Okay, so this is last year before that. What's this? Oh, this is TA. Okay, 310 TA. Okay. 2 lines for that. Okay, I'll read the rest first. Okay, this is okay, let's take a look. Accelerated 100%. Optimizing project, okay. Fixed the holding, okay. Didn't even safety, okay. That makes sense. That's fine. Okay, that's fine. I will say again, I don't think you need to bold the role. Right? The role doesn't need to be bolded. You can get rid of that. The rest, I think your style is okay. You can bold the opening sentence. I think that's okay. I'd say it's not needed, but if you want to bold that, that's okay. No one's gonna fight for that. That's fine. Okay, sovereign intern. Okay, Django Groovy, cream back scripts, and file handling. Okay. I would elaborate on this one if you can. Right? Like, how do you what do you elaborate? Did you reorder the execution order? Did you add parallelism or something? Right? I think there's a bit of more context you can add on this one. Automated device found testing process power structure. Okay, this is fine. This is fine. But you were here for 8 months, right? You were here for 8 months. 8 months, someone's gonna look at this and say, okay, you wrote a Jenkins file script. You wrote a PowerShell script. Okay. So you wrote 2 scripts in 8 months. people are gonna ask you like, what's going on here, right? So I would say, I mean, obviously, I'm assuming you did more stuff. So I think you need to add a bit more context here, okay? And you should do that by getting rid of, like, this is not relevant. You could argue you could put one of these things in, right? But this thing can definitely be lower priority. Let me look at the at the projects. Puzzle games, okay. Screen, team collaboration, okay. Okay, again, you're going for back-end stuff, get rid of that. Instead, get rid of that, put this over here. Put it, say, create a puzzle game with collaborative with 3 people to make to create a puzzle game, something like that. That's okay to put in there. Lightweight SFX you don't need portal collision mechanics. Okay, okay. Okay, this is interesting. This could be, yeah, this is fine. 2 points. Okay, cloud-based app using Lambda. You don't need cloud-based. Press store player match. Okay, integrate right against CPI retrieve match data. Okay, cloud cost. Okay. You can definitely talk about that, right? So how much you decrease costs? You can definitely elaborate on that, right? That could be a really good data point. Okay, this is fine. This is fine. This is a bit light. I think if you have something important to put in this experience, put it there, right? Add it there, and get rid of the second point over here. Pirate Brush, full stack web, Node.js background. Okay, True Monsters. Okay, okay. So I would say, okay, maybe, okay. I'll backtrack on exactly what I said. Keep this, make this 1 line max. 1 line max. This has no content. Make it 1 line max. Especially because you already have this over here. This seems much more complete and relevant. In fact, you can even argue get rid of that entirely. If you're not attached to it, I'd say get rid of that. Keep that, and then add a whole point here. Okay. What the hell's going on in the chat? Let's take a look. Are you okay? Looks fine. I was literally about to say whack shit. Yeah. If that guy says, I'd see it myself, but if I see that guy saying whack shit, he's gone. Yeah, submission link. I used to pin it. I'm too bored now. I'm too lazy. I don't want to pin it anymore. So it's just I think I'll just keep it in the description because that way I don't have to edit it every time. So it's a bit more convenient for me. Okay, this guy's comment. Let's take a look. This guy's comment. May 2025 grad. Aiming for new grad positions. Big tech, one start in Canada. Not really home for US and international. Interested in backend systems infra. 3 interviews so far. None with big tech. Okay. 3 interviews so far. I'm assuming for new grad. That's not depends on your hit rate, but that's something, right? Not big tech, but that's still something. That's not bad. Let's take a look. Let's take a look. Oh, you're Ontario. Oh, you're Ottawa. Anything in Canada? Okay. Okay, Carlton. Boom. Don't know what that is. Skills left align. Okay. Ad tech startup. Okay. Architecting and building go gRPC dimension data model survey. Okay. GPU system. Okay. Dimension data model. Okay, that's good. Load dimension data DB. P9 latencies in seconds for analytic work 3 rows. Okay. I like DB. Skill service throughput with concurrent batch. Okay. With Elasticsearch and Pandas. Okay, that's fine. Okay. SCT provision simple time. Okay, that's fine. Okay. This is good. That's sad. Okay, this is okay. New real-time analytics for institutions. Okay, that's fine. Blah blah blah. Champion development. This is new real-time analytics. This is okay. This is a bit weaker. Reporting microservices, query engine, graphical. Okay, this is still good though. This is still fine. I can't. Okay, how can we improve this? Working with microservices, query engine, graphic. I think I'm missing a comma there. Language, join, aggregate. Okay. I think it really depends. I mean, I think it's fine as is. But one thing I will say is that, generally speaking, if you're talking about, querying stuff like that, one of the reasons you would justify using GraphQL or not, you can say GraphQL, but it's a graph query language, is something about the data that is not that you can assume, right? So, for example, like what's going on with the data? Can you describe the data a bit more, right? Is this highly joined data? Is this highly disjoint data? Is it data that is highly referential? So I think adding that little bit of, this is what I say, an adjective actually makes sense. If you can add that adjective description to talk about what the data point actually is, that could go a really long way in selling the reader on why you're using a graph query language. But I think the point is fine either way. It doesn't matter. Okay, analyze UI direction. Okay, that's fine. Okay. Can access. Okay. Single sign class. Okay. So this is last year. This is 2 years ago before. The 2 years before that. Okay. Okay. Whatever. Okay. People are spamming me right now. Whatever. Okay. So let's take a look at this one. The single static. Okay, this is fine. Identify 5 cache read bugs and reducing developers' time to do what? Development time? For 20%? If you reduce developers' time 20%, it depends on what, right? So, I think the English here is a bit off. Code quality, scan prototypes, abstracts, and next tree. Okay, this is fine. Abstract tree, code as database. Okay, so like code mod stuff. I like that. I think this is actually hidden good. This I would say, okay. This is a bit of a soup, but it's one line. You can keep it in. I would personally get rid of that. I would personally get rid of this, but that's fine. What's this? Okay. It's fine. Yeah, that's fine. This kind of stuff, I think 2 lines for these. I think that's about right. Okay, this is a research graph. Okay. Okay. Look, this level of resume, please never mention unit test ever again. Okay. Just get rid of that. Collaborative professors and efficient. Okay. Present with 1 billion nodes. Okay. Plan graph. Okay, this is good. I think this is actually quite cool. I think that's actually quite cool. Projects. You have a Y Combinator project. Okay. 6 SQL statistical function Java. Okay. High-percent database specific for finance. Can adoption for. Okay. This is cool. Cockroach DB. I love to see. String matching, increasing product competitive against PostgreSQL. New PostGIS. Okay. Oh, this is good. I know Uber's H3 geospatial database is always cool. Cool stuff to talk about there. Okay, so overall, what's going on here? So hold on, let me read the situation again. Going for a new grad, big tech, backend systems infra. Okay, I think we're pretty set up for that. I think this resume is pretty geared towards that kind of market. I was in terms of just in terms of passing. Helping yourself pass some more screens, right? Just stop using any fancy like these dots. Left align these. Use a more standard format for that. Otherwise, it's a bit weird. It kind of sticks out a bit. But otherwise, I think there's really not much to improve here. A tiny bit of wording. I kind of outlined tiny bit of wording, but overall, I think the content's fine. It's just a numbers game. Stuff's going on in chat. Working at scale is impressive. Yeah, I think this is great stuff for an intern. I think this is really, really good. I mean, and frankly, I see a lot of full-time people don't even do this kind of stuff. I mean, if I was up to me, I'd fire half the people that I know be kind of lying on their resumes. But that's neither here nor there. Okay, ownership, blah blah. Yeah. I think to be fair, like projects wise, I think this is fairly. I think it's you could probably indicate it's just open source contribution, but to be honest, I think it's pretty obvious. I think it's fine. Good stuff. I think that is fine. Okay, next guy is okay. That's fine. Okay, so this person says, current first year, looking for summer 2025, SWE, data analyst, data scientist, no real work experience, games experience, blah, 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 nothing matters. Okay. Let's take a look. This looks familiar. Okay. DevOps intern, ComSA. Okay, so this is DigitalOcean to DigitalOcean using Git for manual repository deployment. Reducing downtime at 20% and improving experience. Jesus Christ, yeah, that's a lot of downtime for. Okay, that's fine. Streamline DNS management process. Okay, that's fine. This is DevOps, yeah, makes sense. Okay, AML. Yeah, okay, makes sense. Lowercase p. Yeah, okay. Q corner. Okay, so on the web. Oh yeah, this is familiar. Okay. Okay, okay. Actually, yes, okay. This is fine. First year, right? Yeah, pretty good then. Pretty good. I would say all in one application marketplace for React. Okay. So one thing I'll say is that if you have cool functionality that makes this marketplace stand out, you can mention that in the first point. Otherwise, I think the next 2 points are fine, right? So you're saying you have core marketplace features, so I think that's just fine. I mean, like I would say, in fact, if you're just doing core marketplace features, you could argue even get rid of that, but because it's a three line point, it's pushing it, but I think it's okay if you just I think it's okay at this point. Just don't, just generally speaking, don't make points that are too long, right? Separate the responsibilities out, but I think this is the way it's written right now is clear enough, so I think you can keep it. Okay, restaurant, final determinant, blah blah. Okay, that's cool. That's fine. Yeah, and you're indicating it's a hackathon too, so I think that's a good thing. I would say that makes sense. It's a bit weird because you're saying it's a hackathon, but we're doing to present. So is it still undergoing development? So it's a bit confusing here. I think it makes sense to maybe elaborate a bit on this. So maybe elaborate on what was built during the hackathon and then elaborate what's currently being worked on. I think otherwise it's a bit like the times wise it's just a bit confusing. Okay, budget fi. Yep. No, crowd operations, postman. Okay, yeah, that's fine. That's fine. What is this? This is fine. Okay. Overall, I think this is definitely strong for a first year. Some things I would like to see is more depth, right? It's a bit more depth on what's going on. One thing, for example, that hasn't been touched on at all is let me see your note. Your note. Data analyst, data scientist, right? So this would be more like just a general software kind of resume. I don't see anything here about software about data analyst and data scientist, right? Like I don't see anything at all. So, depending on what your expectation is there, right? You might need a second resume for that. You might need some more projects targeting that kind of thing. Now, regarding what we do have on this page, the writing is okay. Nothing to really talk about on that, frankly. I think it just going forward, it's just making more projects, making products that have more technical complexity, right? Having a project that you talk more about, talk about more in detail, right? For example, hackathons on the project. Okay, that's okay if you have no projects, and it's okay if you continue development. But there's things that you would be expected to be able to talk about in more detail as you get more senior. So, for example, one thing I want to see here, right, is okay. Well, what's the performance like, right? So you're talking about using these optimized performance, ensure scalability. Okay, well, what's the performance? What's the scale, right? Like that kind of stuff for both front end and back end, right? So that's kind of the next step that you got to be thinking about. Okay. Joe Malone. how do I recommend apply for jobs? I sort of apply ASAP on LinkedIn through UBC Co-op portal. Anything else? I mean, there's a lot of different job lists that you should be referencing. Tech Career North Discord actually has a bot that shares postings that I recommend you follow. I think Eric actually is the developer of that thing, so shout out Eric. But yeah, like there's a lot of these different lists. Some of them are services like the one Eric has with that provide the listings directly in Discord. But yeah, like just the UBC core portal is not sufficient unless you want to go for those companies. And LinkedIn is usually not a great place to apply because of just the sheer volume of people posting there. So there's definitely other things you can hit. There's a ton of resources, but that's a good question for Discord. All right, this guy. Let's take a look. Okay. All right, so this guy's comment is looking for software engineer new grad roles, focus on back end, looking for security engineer new grad roles. Okay. Okay, no location specified, but obviously they're in Florida right now. Okay, so let's take a look. So imminent graduation. I'm assuming you're a U.S. market here. Okay, so you could probably get rid of that. Okay, okay, Python C. Okay, that's fine. Technologies. Next Ruby on Rails. Okay, you could probably get a Material UI. I don't think that's the most relevant one unless you're going for front end, very very heavy front end stuff to specify. But okay, let's say certification, COBA interview. Okay, I'd say in this case, if you want to put shirts on, I'd say move the entire skills down to the bottom of the resume. But let's take a look. Okay, so research assistant, React on the platform name is college. Okay. Haptics. So I'm not sure what haptics is. I'm assuming it's a capital H, so I'm assuming it's like some brand or something. 80%. Okay. Okay. I would also say for the dates, you should right align them. Right. So align them to this. That way they're a bit more consistent. Okay. Coded and designed a user friendly. Dude. Okay. John Hopkins students prevented. Okay, I would say in terms of the verb order, right? I would say as a nit, you should have it in order of process. So I would say designed and coded, but I wouldn't use the word coded. Coded's a bit awkward. I would say like designed and implemented. Okay. Also, I would say you can just do React, right? So here you have just React. There's no need to put JS over here. New APIs and development tools, Node.js, and MongoDB sorts data from responses, sorts data from Highland. Okay. PHP code base, JS, PHP code base. Okay. Okay. This is fine. A lot of information here. I would consider breaking this into two points, right? Like there's no reason why we should have the migration code, the migration point, and the same thing as the API point, right? So I'd say this could probably be 2 points. It's a bit overloaded. Anyway, yes, take care, Eric. Okay, let's take a look at this remote. Okay. No, I'm just busy. Okay. Okay. The first 3 points are pretty good. The second point makes sense, but as a whole point, it feels a bit unnecessary. You can keep it in for now. Let's take a look at what else is there. Define a stable testing approach. Okay. 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 Just network requests. Okay. Reduce network requests. Okay. Well, one thing you could maybe specify a bit more here, like to be a bit more specific and clear, is talk about if you're talking about reducing the number of network requests or reducing the size of each network request. I would also say you could probably, I don't know if you, I mean this is a while ago now, but like this is the danger of not quantifying things, right? Because I mean, for myself, I know about Amdahl's law, and just because you reduce network request by 80% does not mean that your application is improved by the same amount, right? It's only proportional to the amount that the application depends on the network requests. So I'd say this part, it makes sense, but significant is something which people might challenge in their head. Okay, yeah, that makes sense. This makes sense. Okay. Yeah, pretty diversified. Okay, I see. Okay. Let's take a look. Carbonator. I think the English here is a bit weird, but I like the information. Kind of DB by Azure. Okay, that's fine. Yeah, that's fine. That's cool. Service network. Okay. Okay, so two. So this is like an ML, well, not really ML. This is like a graph kind of thing. You have a bit of uh yeah, a bit of ML over here. This is ML over here. This is just general. This is just general backend. Okay, that's cool. That's cool. What is this? Combination interview that channel. Okay. Okay, so this is like a Chrome extension. Is that, do you have other front end experience? You have front end stuff. Okay, so I'd say this project is quite weak because the scope is low. It's only front end, and you have other front end experience here. So I will probably get rid of this and save the space. I'm not really sure what this is supposed to be. I mean, I see what's going on here, but I don't think that's actually like this doesn't really do anything. So I think you can put the header in, but don't put a point. You can save the point. That's maybe what I would consider doing. Um, and with the room you save for the bottom two, I think you can definitely expand a bit. So if you can expand on this one, that makes sense. The current experience, that makes sense. If you can expand on the, if you can expand on either the neural network part of this or the backend part of this, that could make sense to expand as well. But otherwise, I think it's already pretty full of information, so that's fine. Definitely a diverse resume. A lot of stuff going on there. That's for sure. Okay, moving on. Okay, let's take a look. Okay, this person's comment is, second year comps, a student looking for a Canadian experience internship. Anything software related. 5 signatures last summer, no internship so far. Volunteer intern experiences in India for Venus Go. Okay. 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 If you have gotten 5 to 6 interviews and you didn't get a conversion out of the 5 or 6, that's something you should be focusing on more. Right? Like, that means your resume is passing screens, but you need to focus more on converting an interview into an offer. So of course I'll give you advice on resume, obviously, right? But just be aware that, like, okay, at some point, stop grinding a resume, start grinding interview prep. Okay. Is diverse resume good? Yes, for generalist software roles. No, if you're trying to target a specific industry. But that person didn't say anything specific, so it's good. Okay. I wouldn't put that in. Wait, what year are you? Okay, I wouldn't put. If you're third year already, I wouldn't put that in. Okay. Okay. Um. So this is like, I mean, nice, but this has zero technical information in it, right? Like, what is this using Excel? Is this Python? Is this SciPy? Right? There's no technical information here at all. So I mean, like, what can I say? Um. Okay. Okay. Same thing here. I mean, you had a bit of technical stuff over here, but again, like you need some more keywords. Like you need some like SciPy, NumPy, Panda. Like this could be like it's like pick and choose, right? Like this could have been anything. I can't tell, right? Like you need a bit of detail there. All right, let's take a look. This is good. This is fine. Hackathons. Oh, this is 2 pages. Oh, okay. Okay. Wait, what are you doing again? You are going for what? You're going for anything software related. Okay, I see. Okay. 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 According to okay. I see. Okay. Um. Okay. Okay. Again, this is a bit. It's a fine project. It's a fine project. I wouldn't lean on that too much for actually saying anything about cybersecurity, but that's okay. It's a good project though. JSON. Oh, what is this? Weather information retriever project. Okay. Another encryption thing. Okay, I see. Um, okay. High level advice is I would say you need 2 resumes. Right. Get one for general software development and get one for ML/data science. Right. Like the way, at least the way these two are phrased right now, would do absolutely nothing for an actual software analysis because what is someone supposed to like take away from that, right? Like I can't tell what skill you have in software. So if you want to keep these in, you can keep them in, but I would recommend making a separate ML focused resume for that. And then on your software engineering focused resume, you can still have the experience in there, but really tailor it towards what's going on in terms of the software development. Projects wise, what's going on? Hackathons, a lot of hackathons. You got to cut it down. Too much stuff over here. So I'd say, and the reason I'm saying that is because most of the time on a hackathon, the depth is not going to be there, right? And so I would recommend, keep them in, but just make them 1 or 2 lines each max, right? 1 or 2 lines each max. And then the projects is where you can. But here's the thing: if you really like a hackathon project, you can continue building upon it later, of course, right? But as of right now, the hackathons you're kind of prioritizing above the projects. Now, in terms of projects, what's going on here? The projects just frankly feel less advanced than the hackathons. I'm not really sure to take away from that. If you're just gonna do hackathons, just do do the hackathons. You can do the hackathons. That's fine, right? Stuff like this is not really gonna stuff like this is not really matching this the level of these hackathons, right? And so what a recruiter's gonna take away is you went to these hackathons, and you didn't contribute much because this is what you can do like this is your skill by yourself. This is what you could. This is what you did in hackathon. And this is time pressure too, right? So it's not gonna leave a good impression if there's a big skill mismatch between what's going on in a hackathon and what's going on in your own projects. That's one thing. The second thing is there's a lot of stuff about like encryption and cybersecurity here. You didn't say anything about that, so I'm not sure what's going on there. It's probably just an interest, and that's cool. But again, like if you're just going for general software, like this isn't doing anything, right? Like this isn't general software skills. So if you really like it, either reframe it to talk about software development, or more realistically, like pick one that you like and get rid of the other one. It's not really saying anything. Just just in general. Is specifying products for hackathons important? Yes and no. So, if a project that you have, so a hackathon, but not a project. If it's a hackathon and it's not very advanced, but you really like the idea, you should put it on as specific as a hackathon, so people don't think, oh, this is the best you could have done. No. This is what you did in the 24 hours you're there. That makes sense, right? Now, if it's a project that's not a hackathon, like just your own project, then people are going to have higher expectations. Especially, by the way, you should put dates on. But I would say rebrand it. But judging by the dates, people should be able to tell. Oh, you've been on this project for 4 months. It should be this level. For 8 months, it should be this level. If you've been on for a year plus 2 years, 3 years, it should be at this level. So, yes, there are different expectations for what's going on in a hackathon versus a project. All right, last one. Currently freshman, I'm thinking capable of higher experience, sophomore plus. Want to go to some in-person US prep, per backend, Rust prep, fine. You're not finding Rust, I'm sorry. Full stack, not ideal. Leaning towards startups, more meaningful work. Return from prop training firm you to work at, but I know that repeat companies are bad for experience. I know my resume is mostly crypto. Little worry about that. I'll expand on the number of industries working. Okay, yeah, that's true. Yeah, crypto resumes right now, not too hot. I won't lie, not too hot. But that's fine. That's fine. Let's take a look at that. Okay, where am I? Here I am. Okay, so Waterloo, chill. Okay, looks fine. Okay, so we have. This is okay. So you have experience over here. This is a different one over here. This is all Solidity again. Okay, this is all Solidity. Oh, this is all Solidity. Oh, okay. I see. So project. Okay. Rust, Python. Okay. See, I would split that into languages. Okay. I will also say that you're doing a lot of Rust preference, but you have details for all the other languages. What's up with that? Right? So if you have Rust, I mean, like, if you have Rust stuff, put it in. Right? Yeah. It's not a big deal, to be honest, but you have the room, you can put it in. What's it called? ArcX, Hyper, stuff like that. If you have experience, some people might be looking at that, right? Now, let me be real with you, right? No one's got Rust on their ATS, right? But if a human looks at it, oh, you have a Rust resume, and they look at it. If you have something which really, if it's looking good, if they recognize some of the stuff you're using, that could be pretty good. So I think that's like a bonus kind of thing you can put in. Anyways, okay, so let's take a look. Rust versatility, okay. You can change Rust type, okay. MEO, okay, okay, nice. Okay, maybe I just don't understand what MEV is very well, but I don't understand how you can boost a success rate by paralyzing data processing, right? Like, this feels like a performance increase. This thing feels like a success rate booster, and this is also a performance booster. So I feel like you're conflating a couple of things at this point. Managing 200K plus market manager energy. Okay, that's fine. Manage by funding market share. Okay, Wait, what is that word? Functionality. Market maker functionality. Okay. Okay, market makers like that. Volume client tokens. Okay, volume stuff. So this is very quant focused. Okay, that's fine. That's fine. I mean, like stuff like this, stuff like for example, we're talking about Oracle. You're talking about stuff like for example, what's going on like volume, market making, right? Like this is applicable to also non crypto trading, right? So I think that's fine. This is good. Enter crypto. Okay, that's fine. Doesn't matter. I say this kind of point. Okay, I'll look at the resume. I'll decide if you should get rid of that or not. That's like this is just not the same level. Okay, let's take a look. What's on comment? Specifying products. Oh yes, I gotcha. Oh okay. The algo had latency issue, but that would take more time to explain. Yeah, that would take. I mean, yeah, that would take more time. I think it's fine. If that's the case, that's fine. They can ask you that in interview. But also, how is latency solved by parallelization? That's also a bit whack to me, but whatever. Content developer, no date here. What's going on with that? No date. Perpetual futures. Okay. Sure. Okay. Line of finish is cool. Okay. For school, unlike communities. Wait, what? Okay. I see. This is a contract. Oh, okay. I see. This is just different work. Okay. That's fine. Okay. This is. 10% all times. Okay. Wait, what is this? Reduce user transaction fees by minimizing storage and memory use. Core logic. Okay, I think this is too crypto specific for me to understand. I don't understand. Like, are you charging the fees? And so if you increase your efficiency, you charge less fees? I guess that's my interpretation. I don't know if it's correct or not, but I mean, I guess that's fine. It's a good thing. So I guess it must be okay. Projects. I will put dates here if possible. Okay, let's take a look. Huff EVM. Okay. This is for Rust contribution. Okay, this is good. I mean, put a link here. Right, put a link there. That's good. Okay, risk manager 12. Training teams. Blah, blah, blah. That's fine. Project. Okay, that's fine. Yeah, okay. If you don't want tracker. Modules in real time. Okay. Wait, what? Decoding powered. Oh, generalized call data decoding powered. Okay, ChatGPT. Okay. 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 Call data. Okay. I think this is cool. I think the ability to execute on chain ripple. Okay, that's cool. Sure. Okay, this is something. What is that? Solidity. Okay, Solidity. Solidity for test net token distribution based multifaceted. Okay. On-chain data improve humanity test is rare. Okay. I don't know. I have no idea what this means. Okay, I'll be real. I have no idea what this means. It sounds interesting. The second point I understand. The first point I don't understand what's going on. But if you're going for like crypto jobs, maybe they'll like it. I can't comment on that. I don't know what's going on there. Cross-chain print for extended keyword because of okay. Okay, makes sense. Foundation analyzing machine affecting DRS between for F1. Okay. I think this is cool. I think it'd be even cooler if you because you have a plot, right? I think even cooler if you could link it or something. I think that'd be even cooler. But that's fine. AI calendar assistant. Here's the AI app. Here we go. Okay, that's fine. I mean, okay, that's fine. What's the question again? In-person internships, US. Okay. Backend. Okay, so first things first. What's going on here? I mean, a couple things. If you're going for crypto things, I think this is great. Right, crypto stuff, that's great. If you're going for trading-based things, that's great. I think that's fine. If you're going for general stuff, like general back end, that's not crypto, that's not trading. The fact of the matter is, this is lacking a lot of like just baseline information, right? So for example, Rust backend stuff. You have a Rust back, like this is Rust backend, right? This is like I don't know what this is. This is like a tool, probably backend based, right? like a lot of stuff here, but it's missing the common kind of check marks that people will be looking for, right? So for example, you have like so you have node over here. Node, good. People love node. Now I hate node, but people love node, right? But there's not really much talking about node in here. Right? You have it listed here, but not much talking about it. So I think if you want to like optimize a resume for just general backend roles, right? I'll be frank with you, like condense or get rid of some of these Rust crypto things, okay? And you just gotta put in a regular backend project, since it's regular. Or I'd say, and this is because I don't really understand what's going on with these, like what this actually, like first of all, I don't know what this really entails. I don't know what it takes to achieve that. I think if you really like these projects and they have some back-end depth, you should expand on these points, talk about some more back-end concepts, talk about how you're making these API requests, talk about how you're making caching, storage, databases, right? Database is another big one. I don't see a single database here. What's your database? There's Django sort of, right? Like you gotta hit some of the regular back-end kind of data points here, right? So a lot of things here is impressive, but if you're talking about optimizing a resume, it's not about making every point as impressive as possible. It's about making points impressive in the context of the job you're going for. So I'd say that's kind of thing you got to rework a bit. I think by the time you get to about here, people already understand you. Okay, this person knows crypto. They know a bit about trading. They know a bit about what's going on for optimization. They definitely know crypto because they see what's going on with these NFTs and these what's going on here again, right? The client tokens and that jazz. Right, so you gotta have some more points about just regular backend stuff for the sake of employability. That's how I would say. Or I would say if you don't want to get into the crypto stuff, keep the crypto stuff around. That's fine. Just rebrand the points to talk about the backend. That's okay too. All right. Wait, where's my notes? Here it is. Okay, we're at time. We're actually over time. That's all, everyone. Get out of here.